Welcome everyone to the final day of the winter school. I think, we started with a lecture on how biology influences your choice. And after that, we had, lectures on environment. We had lectures on econometric techniques. And finally, we have come to a macro session, which as sort of, as you would expect, macro is going to combine micro and all the insights together. So that's why we kept it for the best one always comes at the last. So macro, and we are also going back to biology, the connection between biology and economics in some sense. So we are going to talk about, so we are going to come into full circle. So it's my pleasure and indeed a privilege to introduce our speaker today, Raouf Boucekkine. I was asking him about, pardon me for all my, pronouncing this, I don't know, I was asking him about this, but I'm trying to, I'm going to try. So Raouf is currently an Associate Dean of Research of Rennes School of Business, and Professor and Associate Dean, but he's also at ex-Marseille School of Economics. And he has also taught earlier at Université Catholique de Lyon. and so basically he has a very he has been in many different places, taught many different courses. He's also an associate editor of many different journals, including the Journal of Economic Dynamics and Control, one of the top field journal in macro. I'm not going to bore you with his long list of publications simply because I can't read them out, and by that time the lecture time will be over. But I want to tell you that he has worked on many different topics, macro development, growth being one of them, but epidemiology and demography and also political economy. So the breadth is really stunning. What I want to tell you is that, as I was going through, I know I'm familiar with his work, but as I was going through his list of publication, two things struck me, which is that he had worked in a way back in 2009 and 10, he had already worked on the distributional consequences of epidemics and how epidemics induce behavioral change. So this was, way back before COVID. So in a way, we talk about macroeconomics, we use in our model perfect foresight a lot, but I suppose this was an example of perfect foresight coming up from a macroeconomics, talking about the effects of epidemics on growth, development, macroeconomy. So he's going to talk today about a little bit about that in the first lecture and the second lecture, and then more or less. So he's going to develop on that. So without wasting any more of your time, over to you, Raouf, for your first lecture. Thank you.
Then you tell me if it works. Okay. So thank you, Mausumi, for these nice words. I'm of course delighted to be here. First time I visit India. I have visited almost all the Asian countries, more frequently Japan than all the other countries, but I was delighted to be in such a genuine country. Yes, to give you a more global and maybe more precise picture of what I will teach my lectures today, I will start with something which is roughly a review of the way economists dealt with epidemics. I will show you the different approaches that have been followed. And I will talk, among others, about this literature, which was actually flourishing 1 decade ago, about the impact of mortality on the development process, which when you talk about mortality, what you have in mind, and that's precisely the kind of frames I will develop. What we have in mind is the consequence of some enduring epidemics, which are, well, let's say chronic diseases of like malaria, like etc., which are enduring, which last a lot of time. And precisely that's how I came to epidemics. I was actually advisor to the Belgian government working in Africa in the one region called Great Lakes region with Congo, and Congo is almost the mother of all the diseases. So I got interested. That's to answer to comment on what Mausumi said a few minutes ago. Actually, I started because I was in Congo from 2008 to 2013. I got interested in political economy when I started as advisor in Algeria. You see, so that's when you are curious enough intellectually, so you got interested in what you see around you, and then you got to that basically. So I worked more precisely on AIDS, on HIV AIDS. That was my first specialization in economic epidemiology. Oh, there is a dog there. So this is how I got to that. That's nice. That's fine. That's fine with me. And then that's why I know very well the work which I know more than very well the work which has been done by Mausumi, Shanka, Chakraborty. I will talk about the distributional impact of mortality, and I will mention one approach which is due to Shanka and Mausumi at the end of my talk. I also worked on the impact of epidemics on poverty and inequalities, in a paper published in 2010, but it's much less interesting than the one of Mausumi and Shanghai. I say it very sincerely. Mine is rather technical. First lecture, I will give you a survey of what has been done in economic epidemiology before COVID. Second lecture, I will tell you more about the new literature, which is driven by COVID, actually. And the third lecture will be my own new papers on COVID, since I think it's somehow consistent. So let me start now. So the basic thing I want to tell you is that things are really changing on this front. You see COVID everywhere, as you know, and you don't see it only in the numbers, the inflation numbers and things like this. You see it in research. In all disciplines, you cannot imagine the number of papers published in all disciplines, not only in epidemiology, in economics, in geography, in all things. General journals, etc. So I call it a tsunami. It's a tsunami of papers. Even journals you couldn't suspect of being interested in epidemiology have been publishing special issues. I'm mentioning this journal, Regional Science, the Journal for Regional Science. You see, and I myself I have co-edited 3 special issues. I will tell you more about the 2 first I have, which are already published. This one is underway. It's more on the mathematics of economic epidemiology, and more importantly, you have this new way of publishing. You know, when this COVID started, it was like a terror shock, not only to people but also to researchers. I will explain this in a minute. And then we have to change a bit the rules of publications. Papers should be published more quickly, even if they are imperfect. And this, for example, is perfectly reflected in this new publication, which is called, I don't know if you heard about it, COVID Economics. It's published by the CEPR, which is one of the most respected European institution. And it's basically this journal was publishing almost on real time, without deep reviewing process, as the economists like. This flow of papers, more or less interesting, of course, but we were all lost at that time. We needed to have contact ourselves to show first results, etc. So if by chance you get in this, you will have it. As I told you, it was a shock. It was a shock to everybody, starting with the epidemiologists. I remember one famous epidemiologist in France called, I don't know, maybe you know him because he's very famous now, Didier Raoult. So he's one of the guy who came with the hydrochloroquine or something like this. You remember this? So they thought, I think most of them thought that this, I'm talking about the epidemiologists, that it's a new respiratory virus, probably like all the others which have been coming out in the recent, from the beginning of the century, it will vanish by itself. No problem. Like we got, you remember the bird flu? Well, you are too young, but most of are too young, but it's a virus which actually started in China, in Guangdong in 1996, had some casualties, of course, but then the impact was rather limited. Everybody was thinking about the same, that we will have the same with COVID. So they were surprised to see that, well, we are still in COVID, actually. Well, we don't wear masks because, well, not everybody, at least, except the lady, but we know India, Brazil, Europe, we have all lived periods, very long periods of lockdown, etc. And we are still in that. And you see what's happening now in China. They are changing their policy. So things are changing very quickly, and we are going, that's my impression when I'm not, I'm not a real scientist in that. I'm just working on that in collaboration with other people. But those who know now are epidemiologists, they think that we are at the beginning of a period of time in which we have more and more emerging and re-emerging diseases for many reasons I will try to explain. It has to do with the ecological crisis. Think about how these zoonotic diseases came out. They came out for certain reasons which are not all linked to human behavior. They are connected to climate change, they are connected to the destruction of biodiversity, they are connected to many things. So it could be the case that we are in the beginning, actually, we are in this period, in this kind of situation since the beginning of the century with this, I mentioned bird flu, etc. We'll have many things like this. We have to prepare ourselves to this kind of phenomena, repeating every, I said, 3, 5, 6 years. So we have to understand how to deal with this kind of diseases. But one thing should be stressed from now, this is the first time in the history of humanity that this an epidemic has provoked this kind of massive interventions. Maybe you know this word, non-pharmaceutical interventions. Normally, when you have an epidemic, you can, well, most of the time with short delay, you find a cure and it's finished. Here we had to stop the epidemic using very unusual methods. Lockdown, we all experienced this lockdown, but it's not only lockdown, it's the scale of the lockdown. It's completely unprecedented. The macroeconomic effect is massive, especially for COVID. You see that the singularity of COVID. If you look at the historical record, I can give you some references. Most of the epidemic episodes have led to, let's say, mild period of recessions, no inflation, nothing really bad. What we see now is probably the unique epidemic episode with leading to inflation. I'm not saying that the current inflation is only due to COVID, but it's the unique epidemic which generated such an intense inflation. And as I told you, this is concomitant with an ecological crisis and certainly connected to this ecological crisis. I'll show you some pictures here. So I was telling you that it's the first time in the history of humanity that we could see this non-pharmaceutical interventions at that scale. And the unique exception I have in mind is one thing which took place in the south of France in the 18th century. You know, at that time, waves of bubonic plague were taking place. The last one took place in Marseille, southern France, in 1720. And the cities which are situated just behind well, erected this wall called le mur de la peste. That's the wall of the plague. It was erected on the mountains just before Marseille to stop contagion from Marseille. Just 25 kilometers. Okay, it didn't stop anything actually, but it was erected to this end, and now it's a highly visited touristic place. That's, you see, but it was just 25 kilometers. You see, now we're talking about a non-pharmaceutical intervention at such a big scale, at world scale, not only at a regional scale, at a world scale. So it collapsed almost everything before the lockdown. I show you this picture. You remember in Italy, they started by a partial lockdown because the the epidemic started in Italy, in the north of Italy, in the region of and then the government just announced that from that day you will have a partial lockdown in the north of Italy. So all those who are living in the north try to migrate to the south. And then the government, Draghi government, decided to extend the lockdown to the whole country. You remember this. So it collapsed everything before the lockdown and of course after the lockdown. So if you see, this is the main airport in France called Roissy. I came from this airport. So at that time it was, you cannot imagine to see Roissy like this. It's completely empty. That's incredible. It's always full, you see. So you can, of course, imagine that it was the same case in all the transportations things. And everywhere, actually. That's the perfect thing, the perfect image you can have of the collapse of the global supply chain. That's, of course, because of the disruptions of this supply chain that we have all the problems we see now in the inflation and things like this. Now, this is just a short introduction, and now I will show you. Have to be a bit more fast because we have many. So here's the situation. In this first lecture, I will show you how the economists have been dealing with epidemics along the way. We start from the beginning. So the first approach, which I call l'enfance de l'art, that's the beginning of everything, was initiated by a great economist. Actually, Shanka knows him. He was in California, Jack Hirschfelder. It's the disaster approach. I will tell you something about the disaster approach. I will try to be not too much a mathematician, because otherwise you will, so I will reduce the mathematics, but you will see some slides with formulas, I'm sorry. And then I will come to the historical perspective. I will talk about unified growth theory. So the first part will be disaster approach, but I will put some growth theory. This is my initial area of research. So I have done some research in this before even being interested in epidemics. And then I will finish with the third line of research, which has been extremely important after the start of the HIV AIDS crisis, to which Mausumi and other friends have contributed to. Okay, so let me start with the very first attempt to bring an economic analysis to epidemics. As I have just mentioned, the guy who came with this is Jack Hirschfelder. So he's a great guy. So if you are interested in reading a great intellectual, read Jack Hirschfelder. He has a very famous book on economic behavior in the face of adversity. And one of the adverse shocks is, of course, epidemiological shocks. So please read him. Shanka has approached him. He was a professor in California. Maybe you met him too, right? Not, but you know him, yeah. So he has this. He was actually ordered by the Rand Commission, you know, the Rand Corporation. Sorry, the Rand Corporation told him, "Well, can you tell us what would happen if there is a thermonuclear war?" Okay. We are in the 60s. Remember the 60s? Is the Cold War. So they were maybe anticipating something like today. They are just, you know, the story is repeating every day. And the guy was just, okay, what would happen if there is a thermonuclear? Or is there something similar to this? Well, he thought one perfect parallel could be drawn between this thermonuclear war and what happened in the 14th century with the big plague epidemic. You know the plague epidemic? The bubonic plague, 1348, 1352, but you know that there have been several waves. Every summer, basically, at that time, you have this kind of contagion, this kind of like COVID now. Every summer or not every fall you have COVID. So there was the same. Okay, and the guy focused on the big plague shock, the one in the 14th century, which killed, according to many reports, more than 1/2 of the European population. So, what were the consequences of that? Well, you say but then he, of course, saw that there was a massive destruction of human capital, some implication. I will come back to this on the fall of the feudal system, the emergence of like a more capitalistic agriculture, things like this. So basically, and then, well, he ended with, so this, he tried to draw a parallelism with wars. And actually, this is what the textbooks do. The most famous one, I don't know what is taught in growth theory here in the Delhi School of Economics, is Barros-Alain-Martin. You teach it. So if you read Barros-Alain-Martin, chapter 4, chapter 5, you will see the story of parallelism between war and epidemics. And actually, it comes from Hirschfelder and his famous report to the Rand Corporation. And well, Hirschfelder was not really, at the end of the day, when he finished his report, he had this comment: direct inferences can hardly be drawn. I will try to show you, but as I say to, I think that's here is this is the comment. Direct inferences can hardly be drawn from this 14th century as to possible consequences. he was not convinced himself. But at the end of the day, well, all the economists were following this disaster approach, actually. And the counterpart in growth theory is what we call imbalance effect theory, to which I have contributed a lot, how many years ago. But I will tell you how pure mathematics, actually. But I will tell you basically the kind of things we can say on benchmark models. So the thing is, when you talk about this disaster, you have to look at it as a disaster. Normally, disaster is short-lived. Something happens, an earthquake, I don't know, yes, an epidemic, a war, it's short in time, it's short-lived. And mathematically, it is treated as a shock on the initial conditions of a dynamic system. I will tell you this in a minute. It's not applicable to enduring epidemics, like the one we have been working on. I mentioned HIV or malaria, or it could be COVID. In 5 years, it will be always here, and we'll talk about. So this is really why this parallelism holds, because we are talking about initial condition shocks. All the rest, what we call now Epi-econ literature, is something which has emerged much later. I will tell you, but actually one of the most important contributors is an Indian researcher, Aditya Goenka, who is a very close friend of mine. Okay, so I will tell you more about this in a minute. Let me just say a word about the disaster approach. I will tell you which kind of economic research or intellectual research questions we ask. So the examples are the Spanish flu, 3 years, or not 3 years, 1 year, and the Black Death, 3, 4, 5 years. It depends on the sources. So short periods, well, the Black Death, if you take the millennial perspective, is very short. So two main questions: what are the short-run consequences of this? Shocks, interpreted as initial condition shocks, on the size of human population, human capital for epidemics, and on physical capital for wars. What are the transitional dynamics? And then, could it be the case that these initial condition shocks have long-term effects? these are the questions which are treated. We treat them with this. Oh, sorry, I'm not very good at that. So we treat them with this imbalance effects. I will tell you more. Well, it's not trivial. You know why it's not trivial? For technical reasons. When we get to endogenous growth theory, I will tell you this in 1 minute. If you want to inquire how shocks on initial conditions affect the long term, then there is a problem with the methodology in economics. I will tell you more in a minute. But you see the problem with endogenous growth theory by, I don't know if you have some background on exogenous versus endogenous growth theory, but in exogenous growth theory, the long term is independent of the initial condition. But endogenous, in endogenous growth model, no. The problem is that the economists do not really care about this. They just simulate and see. But if you want to have an intellectual view of this, you have to develop a theory which connects the initial condition to the long-term outcomes, in particular to the levels. The growth rate, we can always compute them. I will tell you this in a minute. So some mathematics, it's one of the very few slides. I used to do more mathematics, but here it's almost, I would have taught like 3, and then I promise almost no mathematics. So if you consider a dynamic system like the one you can extract from optimization of a growth model, suppose it's a vector x, you have n variables collected into a vector x. You see, this is vector x, and you have the dynamic system. Suppose it's autonomous, so f of x. So what the economists usually do is to find a solution for the long run called balanced growth path. You remember this? So they basically solve for this parameterization. Okay, if you have n variables, then you have n unknowns. But if the growth is endogenous, then you have n+1 unknowns because g is unknown. So at the end of the day, you will end up, when you replace with this parameterization, this parameterized path, you will end up with an equation, but with n+1 unknowns. So there's a problem of indeterminacy here at best. What economists do, including my good friend Jess Ben Habib and others, many papers published in the Journal of Economic Theory on that, they reduce the dimension by, instead of solving for the original variables, they solve in ratios. That's how we teach, right, Mausumi? That's how we teach this kind of things. So, but at the end of the day, what you get in the balanced growth path is not the level of k, is not the level of h, you get the level of k over h. So you cannot answer the question I asked before. In order to do that, you need to do something to solve the dynamic system in closed form. Or you run numerical simulation, but if you are a pure theorist like me, you don't like numerical simulation, so you have to try other things, okay? Okay, so I will tell you how economists are doing, which is exactly how it is treated in Barros-Salai-Martin. It's not mathematically correct what they are doing in the textbook, but we forget about this. It's just so the correct solution of that, you can find it in a paper I edited for the Journal of Economic Dynamics and Control by Gomez, 2003. But it's a textbook, so okay. So sorry, the model, I will show you how it's treated very quickly. So you have one sector model is the one in which you have only one good, and this good is produced. And you see, it's produced with a technology which is called Douglas. And since it's a one good, the good serves to consumption and to investment in both assets, K and H, which are ex ante perfect substitute. When you equalize, because they are ex ante perfect substitute, the marginal productivity of capital, you have this equilibrium level. K over H should be equal to alpha 1 minus alpha. This is what you should have seen in your lectures. Okay. One important thing is to add this irreversibility constraint, otherwise the problem becomes trivial. And then you ask the question, what happens if initially you have a shock which makes you depart from this equilibrium level? If K0 over H0 is bigger than K over H, then it means then that you have a short age in human capital, like an epidemics. If it's lower, it's you have a war. The basic, you solve this problem. And the basic result you get is this one. So, oh, sorry. Oh, I'm going too far, as usual. No, this is too far. Okay. Okay, that will go fast now. This is the original thing. If you treat capital, human capital and physical capital the same, symmetrically, you get this picture. And this picture tells you that this is the growth rate of output. And this is the famous ratio K over H. At equilibrium, you have this level of growth rate. This is the permanent regime, if you want. If you depart from it, then you have dynamics. So the larger the severity of the epidemic, remember that in your region, in this region, K over H is bigger than alpha. So this is the epidemic shock region. The larger the severity of the epidemic shock, the larger the growth rate in the transition. Same thing, the most severe, the more destructive is the war, the higher the growth rate during the transition, which means that these shocks are followed by growth miracles. What we have in mind, basically, for the wars, you can understand it, the wars are this side. It's exactly what happens in Germany, etc., after the Second World War. That's typically a neoclassical adjustment because your physical capital falls a lot, the marginal productivity of physical capital is huge, and then you will invest a lot and you stop investing in the human capital, actually. That's the story. So you invest massively only in the factor which is in shortage. Okay, so, and you see this perfect symmetry between epidemics and wars. Of course, nobody has seen any kind of miracle after an epidemic. So there's something is not going well here. So what people usually do is to introduce an asymmetry by putting adjustment costs, which are much important when you have a shortage in human capital. And in this case, you will flatten the the right-hand part of the curve, and while you still have growth miracles after a war, you no longer have this, but still growth is positive after an epidemic. You see, it's above the equilibrium level, which is still not the kind of things we see. I advise you to look at this Vox EU blog, which is published by the CPR, in which we have several studies on that. And basically, what would be perfect is to have something like this. Decrease, actually, because nobody's, or something much flatter than this. Even if you put maximum, you cannot make it decrease. Okay, the adjustment cost will just flatten it. You will not have something which goes to. So in order to have something, I will finish with this. Don't give you too many details, because otherwise I will spend all my first lecture on this. Of course, things become much more reasonable if you take a model which is more reasonable, that we do not produce human capital the way we produce physical capital. Because that's the famous two-sector model due to, call it Lucas Uzawa. The first who came with this is Uzawa, of course. So the idea is that we have a sector which produces physical capital and a sector which produces human capital. Okay, and if you look at the powers here of H, here is 1 minus beta, and here it's linear. So the human, so the education sector, this one produces human capital, is more intensive in human capital. It's key. That's the two sectors do not have the same. Okay, and then thanks to this, you have this picture. Yeah, just to mention here, since we have two sectors, GDP is not only the production of the final goods sector, you have to add also the production of the education sector. So H point is the output of the education sector per capita. Remember here that we don't have schools, we don't have universities, it's self-education. We multiply. P is the shadow price of human capital. Okay, so that's it. And then, well, that's what you get. That's okay. And then you can ask the question why you have that. The reason is very simple. If you have a shortage of human capital, then, as you know, because we assume that labor can freely move from this sector to this sector, from final goods sector to the education sector, H is into two places, right? Assume that H can fly from one sector to another freely. Then wages are equalized, right? Suppose you have a shortage in human capital, then marginal productivity of human capital will be very high. The wages will be very high, okay? If the wages are very high, then, of course, the production of human capital will be much more costly, because the unique sector which produces human capital is the education sector. So if the cost of human capital increases a lot, the sector which is more intensive in this factor will be the most penalized. But precisely the engine of growth is human capital. You see the story? I repeat, labor or human capital flows freely between these two sectors. You have a shortage in H, wages are equal. So here it's neoclassical, right? So you have a high marginal productivity of capital, human capital, large wages. So the operational cost of the education sector will increase sharply. But precisely it's the human capital sector, education sector, which is the engine of growth. So the growth will be retarded, will be dangerously penalized. So these are, I can, of course, impress you with mathematics here, because this is the model I solved about. And using what we call Gaussian hypergeometric functions. I have a publication on this. It's impossible to publish elsewhere in the Journal of Mathematical Economics, because it's very tough. I took this technique from mathematical physics. Of course, I didn't invent it. Okay, so let's move. So that's precisely what we have. And then we can indeed answer the second question. What happens if there is a shortage in human capital or in population? Then we can show clearly what are the outcomes. There will be like a quality adjustment. Human capital in the long run per capita will increase. Okay, so let me move to, I would say, less mathematical things. I just show you the really, as we say in French, the enfance de l'art, the infancy of this economic epidemiology literature. It's about disaster approach, it's about imbalance effect, it's basic growth theory. Of course, the mechanisms are extremely, how to say it, they are extremely simple. What you have is basically cross-sector allocation mechanism in the best case, the case of the two-sector model, and you have also quality adjustment, okay? Like in the quantity quality models. I didn't have time to spend on that, but I can tell you more about it during the breaks. Well, it's a bit short. If you want to look, if you have a look at history and you are serious in how epidemics have indeed affected the course of the economic dynamics, then you will be a bit, of course, you will not find this extremely deep. So I will bring you to another kind of approaches in which also I have also contributed. It's what we call a unified growth theory, which looks at history, how mortality shocks have affected structural change and the like. I mentioned the paper of my good friend Nip Lagerlof, who's the guy who worked on how epidemics have actually impacted the transition from the Malthusian regime, you remember, Malthusian regime to modern growth. And I have several papers with David Delacroix and other colleagues on the role of mortality. Not epidemics, strictly speaking. The unique guy who does this correctly is Lagerlof. We are just elaborating around. I will tell you. There are other papers who question the view that we can think of the Spanish flu or this plague as having being pure initial condition shocks. And I will mention one. And I will finish with the implication, with the last part of my review, which has to do with enduring epidemics. It's very important literature, which started to be really important, I would say, after with the AIDS. And as I told you, Mausumi and others have in a way contributed to this literature. One, yeah, please. You can ask all, yeah, I forgot to tell you that you can ask all the questions you have in mind.
Yeah, so I was wondering, I mean, you started by saying that there are shocks in disasters, right? As opposed to epidemics, which are long, spread out, let's say. So what is the role of formation of expectations as regards capital? I mean, shopkeepers, etc. I mean, can they have confidence in, bringing back capital easily? And
in which sense?
In the sense of forming expectations, that is the pandemic about to get resolved sometime soon or not? That may
this is more, if it's about behavior, we'll talk about this later.
No, but within a rational expectations regime, can something?
Yeah. We of course, we are all working with expectations. So we have dynamic models, so we have, of course, this kind of responses. You see, your question is about how people respond to epidemics having this expectation. Yeah, though how they form this expectation is a different issue. We can talk about this later. So I just wanted to show you something which has to do with this view of epidemics as short-term shocks, as initial. Mention this one. It's very interesting research brought by Douglas Almond. I don't know if you know these guys. He's a very guy, but he's bringing. The guy will simply show through his fatal origin hypothesis. That's a very important hypothesis, that even a short-lived shock, like for example, the Spanish flu, actually he will concentrate with his co-authors on the Spanish flu. Remember, Spanish flu is few months, I say 1 year, 2018, 2009. So you could imagine, if you use what we say, that nothing very strange will happen, but in the long run. But these guys bring something new. I will tell it in one slide, and then it's your job to have a look at these papers. They're very easy to read, applied, so you can understand everything. So the idea is this one. And actually, the guy applied it to many things, like, for example, the fate of babies born during when the mothers were pregnant during Ramadan, for example. It has many papers like this, uses exactly the same thing. So his observation is the following: during the flu, the famous Spanish flu, you know that the specificity of the Spanish flu, like actually COVID, is that it affects adults, while the typical young adults, while the typical flu will affect only the youngest and the oldest. Okay, so among these adults, approximately 1/3 of pregnant women contracted the virus. Okay, so that's first observation. 1/3 contracted and they were pregnant. Okay, and then approximately 2/3 of those in utero during the height of the pandemic would have been born in the first 6 months of 2019. Okay, we have now the beginning of the picture. Then what the guy says the following: those who were in utero during this period, normally we should find them in 1960, 1980 decennial census data. Okay, and look at their basically performances. And what the guy observed in his American Economic Review paper 2005 is that the cohort in utero during the height of the pandemic, the one I mentioned, displayed the reduced educational attainment, increased rate of disability, lower income, and lower social status. So there is like a retarded effect. The shock was short but intense, and there is like a fatal heritage there. Okay. Okay, now that's what he found, actually. And as you see, there is nothing which explains why these bad performances, I would say, are linked to the the health status. That's why he completed his study with another one. It's published in the American Economic Review Papers and Proceedings, using another, the census has no data on health outcomes and pathways. So he moved to this. Actually, I'm not an empiricist, I'm just citing the, so it's a survey on income and what's the base? Is P and program participation, okay? And then he can identify the health pathways. And he found that cohorts in utero during the pandemic exhibit impaired health outcomes. So this, it completes the picture relative to cohorts born a few months earlier or later, okay? The conclusion, of course, is that, of course, the Spanish flu took place in 1 year, in 1919. However, the impact is highly visible, according to these guys, 65, 80 years later, after the pandemic. That's the famous fatal hypothesis. Okay, you get the point? I'm not totally convinced about this, but this is the kind of things I'm obliged to mention to you so that you have a complete picture of how you can evaluate, I would say, this the literature on disaster effect inherited from Hirschfelder. This is one. The second thing which goes against this view, this simple view that disaster analysis. I have like 45 minutes left, right? Okay, so we can proceed. Is history. Look at history and see whether initial condition shocks do not have long-term effects. Or do not have strong long-term effects. So in this, I would say that economic historians, I don't know if by chance you have read some economic history books by the main guys in the field. I was really astonished by this guy, David Hurley. He is an American economic historian. Actually, he was the president. He was because he died. He passed away. He was the president of the American Association. He published this famous book, The Black Death and the Transformation of the West. The guy is more specialized in Italy, so most of the arguments are taken from the Italian experience. And he simply tried to make the case that what happened during and right after the plague, the Main plague wave, the 1348, 1350 something, is absolutely important to understand what happened in the West, how the feudal society was destroyed, how capitalism arrived, and how a certain type of technological progress. The idea is the following, and I will explain it later, applied to AIDS. When you have this shortage in labor supply due to these mortality shocks, then you have scarcity of labor. We agree on that. Scarcity of labor means that you have to find a way. It's to overcome this scarcity. This is what we used to call Hicksian technological progress. And that's what the guy is claiming, actually. Well, I'm not sure he knows Hicks, but, and then the idea is to say, well, because we have to deal with this scarcity, we invented new ways to perform the task, and we invented other actually approaches to. He mentioned, for example, he has an interpretation of the Gutenberg machine. Gutenberg machine is the first printing machine in the history of humanity. You know who were the people who were writing the manuscript before were the guys in the churches and in the monasteries, you see? Then his idea is, well, of course, the plague didn't spare the lives of these guys. It was equally shared. So the death shock was for all the categories of that's why precisely the feudal system went down right after this, well, few decades after this. So the idea here is that this scarcity, because of the violence of the mortality shock, very, very big mortality shock, the society, although it took place in 2 months or even in 1 month, if the shock is very, 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 very big, something has to happen, because the prices, like the wage, etc., will sharply change. The economic agents have to adjust to that. They adjust, and they adjust by going to other ways of innovations or productions, and that's what we call basically structural change. Okay, this is also what we. You have any? Do you have any question on that? So I think it's a good book. You can read it. It clarifies many things. What we have, yeah, please.
Does your theory also extend to? So does your theory also extend to other types of huge population reduction, like, for instance, King Leopold of Belgium killed one half of people in Congo. So does your theory also extend to?
Yeah, in this case, you see something which is very clear, that we are talking about a situation in which here we're talking about Europe, and with people free to entrepreneurship was free, etc. We are not mentioning countries which remain still under Leopold.
Okay.
Yeah. No, this is of course not applicable to the poor African countries at that time. Couldn't do. So the other theory to which I have contributed a lot at that time is this one. So it's what we call UGT, is unified growth theory. I just spent a few minutes on that because I think it's quite important. And here the question is, what the typical objective of unified growth theory is to understand growth from a different perspective. While the typical neoclassical growth theory studies growth and development, focusing on the post-war period, basically. And this one, unified growth theory, started from the origins of humanity. So it considers at first the question of how humanity succeeded to transition from the Malthusian trap to modern growth. You remember that this is the objective of unified growth theory. So related to this, the question is, did epidemics play a role in the pace of the transition, for example? Why it took, I don't know how many centuries for humanity to take off? Why this famous modern growth regime only occurred in the 19th century and not in the 17th? Basically, that's the question. So did the epidemic play a role in that? So that's so we had a certain view with my co-authors, David Delacroix and Omar Likander and others, that it should be related to that. Why? Because we noticed something. It's very difficult to have data, as you know, on mortality in those periods. You can find data for certain cities, typically the cities which are developed enough at that time. So basically, we found data for Venice, Italy. We could have found probably for Florence, but we find also data on Geneva, and we have the same. So I'll show you just the one we get for Venice. What we observe in this series of papers is that we have, let me first explain. Well, the idea is that we have an early decrease in mortality in the 17th century, approximately 16 something, you see. That's what we call an early decrease because typically people report a decrease in mortality much later, okay? And we can find it here, and you can see it clearly. So let me explain this. This is interesting to see. So this is the age, you see, and this is like a survival rates, you see, survival probability. You could see here 1005, etc. Then you can tell me this is not a probability, right? But it's just a normalization. Okay, so I have to explain. So of course, and here also we removed infant mortality, because if you keep it, then you will have very huge figures at that time. So we start here, and you see that, and we follow different cohorts. That was, we found only 2 data sets in which you can do that at that time. So for Venice, as you could see, so we start in, this is 1.16.0, it's this one. Of course, they are decreasing because with age, survival decreases. That's no surprise. But you can see, my friends, that the survival curve shift upward. Already 20, the cohort born in 20 years later is shifting, especially in the Middle Ages, which is important because these are the guys who work, basically. And same for the others. So what we basically document here is that, at least for, we don't want to extrapolate too much, but there's some compelling evidence that it occurred, at least in Venice. You see this early decrease in mortality, early increase in life expectancy. Indeed. So how to explain this increase in life expectancy in such period of time? We looked at history, the historical papers. We didn't find anything compelling, actually. What would explain this? We thought about nutrition. We thought about health improvements, let's like medical inventions, which would boost more survival. We didn't find anything. So we concluded that, yeah, because as you might, I will tell you later about my good friend Nip Lagerlof. You could argue that medical advances were behind this, but the timing is not good. Medical advances started to be really effective, I would say, from the 19th century, not in the 17th. Cannot explain. Like, it's a puzzle. So the unique explanation we dare to give is to say that with all this succession, the series, the sequence of plague waves hitting these countries, there should be an immunization effect somewhere. That's basically what our idea. Of course, there was no vaccine at that time. It's like natural immunization. And then we connected this to what we call the Ben Porat effect. The Ben Porat is the following effect. It's an Israeli economist who I met him, which explained in the late 60s, early 70s, that having a larger time horizon ahead of you, which you see that's about like your expectations. If you have a longer time horizon in the decision problem you have to make, then the investment problem you have to make, then you will invest more. So the longer you live, the more you will go to school, the more you will, that's our idea. So we adapt the Ben Porat argument to say, since these guys live longer, early enough actually, they could invest more in schooling, and then this probably explains part of the timing of the Industrial Revolution in Europe. That's in our papers, that's what we say. We are not sure that's completely correct, but it's one of the arguments we put forward. And we have some compelling evidence, well, compelling, but partial evidence that human capital start to increase much before the Industrial Revolution. Okay, so we go further, and this is a much more difficult paper. We do it in England, or apply to England from 1530 to 1860. The advantage of that data set of this country, is that they have a very interesting data set on school creation from 1530 to 1860. So we could really track the increase in life expectancy, the creation. So we can track everything, and mortality, technological progress, school creation, and then with a series of as we say, I have to say this. Well, I will skip that. Forgot the name. of the technique, we are able to disentangle exactly how much of this that's what we want to explain. Basically, we want to explain this path of literacy achievement. This is the years. So our data on school creation start from 1530 and goes to 1860. You can observe that there is a takeoff in the curve already in the 60s. That's curious, huh? Because usually our idea of human capital takeoff is much later. And but if you see this, you see that well, this is the 50% line. The 50% line was reached in 1780. So it's connected to something which happened much earlier, because you cannot have this impact on literacy in 10 years. It should take time. That's connected to my, yes, please. I think they will give you the micro. So that's.
You said the immunization played role.
Yeah.
Immunization should also be part of a medical invention. At least, even if it is traditionally it's happened, immunization is part of medical innovation, isn't it?
Yeah.
So that means medical.
No, here I'm talking about. Yeah, sorry, that's a good question, but I'm talking about natural immunization. Natural immunization. So your body is producing. But after second, third, fourth shock, it produces enough, antibody things which block, at least would give you some immunity. It's not with medical advances. That's our explanation. It's like, you see, when you get infected once, your body produces this antibody things, which gives you some immunization. When in the case of COVID, it's not forever, but that's our idea. Because you remember that the plague took place, the plague waves were extremely regular at that time. I give you an example. If you take, for example, all this, let me give you an example taken from history. The Byzantine Empire, Byzantine Empire was very important at that time. From 1348, the date of the big plague, the first wave, to the fall of Constantinople at the end of the 5th century. Constantinople fell in 53. There had been something like 10 waves of plague. So after the 5, the bodies, of course, there's a lot of mortality, but also those who survive become more less certain. That's my point. Yeah, please.
Related question, I know, just with respect to your previous slide.
I will
So
show
the one where you are showing, So the fact that from, people aged between 0 to 15, they're identical across this time periods. Although your carved lines are almost coinciding, the first part of your lines. So it's related to exactly this process that you're talking about, right? Because you're too young, you're not catching the pieces, and it doesn't.
Yeah, exactly. Yeah. Thank you. Good point. So and then we that's exactly what. Oh, sorry, Mike. Sorry, I couldn't say it. Yeah.
In the earlier diagram on balanced growth, where you had.
You came back.
Sorry, you don't need to go back.
No, that's not an issue. I'm ready to. No, I want to show it to you. So which one?
The y dot over y. The y dot over y. That's So in the transitional dynamics extension to Lucas in Dang Yang Z, he needs to assume sigma equals to beta to get these transitional dynamics. So,
oh, you get too far. Okay, I will answer. Yeah.
So my question is, and in that paper, there are all kinds of results about that if countries have are lower, country A, comparing country A to country B, lower physical and human capital, they can eventually overtake if they allocate more time to schooling. So I guess with the epidemic health shock, those results would also seem unrealistic. So looking at this paper you just put up with Mazumdar, saying that there are these persistent effects,
We found in my paper in the Journal of Mathematical Economics, we actually challenged this view of C and etc. By showing that we have long-term effects, even with only initial condition shocks.
Right.
Yeah, and then it's true that that's a good point what you are mentioning.
So my question is, if there are long-term effects, then the Dang-Yang Z type of overtaking results that you get and the welfare results you get would need to be consistent with a story like this.
Yeah. I would two things. One thing is that the story of overtaking is actually oversold, because they are working with ratios, so they don't look really deeply at the levels. The other thing is, if you take the second point is that if you take this one, what is it? Yeah, it's before. No. I have problems with this. If you take the Lucas-Uzawa model, this one, and you suppose that there is like a persistent, we take a persistent health shock, which then of course you change completely the story. That's for sure. And then of course it depends a lot on the ratio, the position of the beta with respect to the sigma. But this is something which is already there. You will find it again here. The difficulty with this kind of models is that you cannot do demographic analysis seriously. You see, it's sometimes and the mathematical cost is heavy. So what I finally decided to do, if I want to do demographics seriously, I move to overlapping generations, and then you can do whatever you want. That's what Mausumi has been doing. Or you move to something more complicated with partial differential equation. But in the tradition of I will show you this too today. Thank you for this. So I see that you know very well the papers of Xi, and yeah, we have the same kind of things, but the difference with Xi and Ben Habib and others is that we solve everything in level, and we don't take this story of crash. Okay, so that's it. That's what I wanted to show you. I just finish before getting to the maybe to finish telling you that when we put all this determinant together, so Ben Porat, mortality, technological progress. So we want to explain this, right? And we have some alternative explanations. One is the Ben Porat, the one I showed you before with the Geneva, not the Geneva, I show you Venice picture, the fact that when you live longer, you probably go to school longer, and then you have better human capital, and then you have this. So the Ben Porat effect is driven by mortality. The second is technological progress. The third is density of population. That's very important. Why it's important, density of population? Not for the reasons you can find it in the original unified growth theory, but for the following reasons. Remember that we are talking about England, and in England we have data on school creation. Schools are created, there's no public public funding of schools at that time. Typically, most of the schools were funded by the church. But you can have also private donors, etc., or basically, well, the most obvious thing is that the families who want to send their children to school, they have to pay fees, okay? So the more people we have, the more school could be created. That's what we call the density of population. The density of population is an argument in the original theory of Gallor and Weil. But the argument was the bigger the population, the more technological progress is fostered. But they have no explanation on that. That's our micro foundation. So this is a somehow difficult paper. It's published in the Journal of European Economic Association if you want to look at it, but because there are many aspects there. So we have the density through the creation of school, mortality, Ben Porat, and the rest is technological progress. We have the data. We have the data of technological progress. So we put this together in a model, and then we ran what we call counterfactual. That was the word I was trying to find. Counterfactual experiments. We have these three things, actually four. I don't want to speak about the fourth. And then we shut down the three, yeah, we shut down three, we let one, and then we compute. Turns out that the density effect is much more important than the Ben-Porat effect. It's the Ben-Porat effect should be one fifth. The density effect is 1/3, basically. And technological progress is the most important determinant of that. So that's to say that here the mortality effect is rather the Ben-Porat effect, which is driven by mortality or by the increase, the early increase in life expectancy is rather dominated by the others. To be completely, yeah, I'm finishing this part with this paper. I just advise you, if you are interested in this historical perspective, this guy is really very clever and original. So if you can read his papers, has some research. He does not publish a lot, but he published very good papers. Niels Peter Lagerlof, I think he's in Canada now. I know him for a while, and he has a much more direct, I would say, appraisal of the link between epidemics and the transition from Malthus to Solo. To modern growth. I'll say Solo because this is typical way you say it. I'm sorry. Okay, so and the guy basically is, and show you this. His case is the Swedish case. It's one of the countries. In case you want to work on economic history, there are two countries with very good data on that, historical data: England and Sweden. Sweden, I don't know for which reason they have such a good historical record, but they have it. Then what you could see here is, so it's a Swedish case, is the what is this? Okay, so this is the time series for birth rate. Okay, you see the demographic transition, right? Started high, and then it went down, and then this is mortality. You see. Mortality, there are two things here. Usually people, when they explain to their students, present in academic conferences, something about mortality and specifically about demographic transition, they only talk about the level of mortality. Mortality declines, as you used to say. But the important point made by my good friend Nipe is that you could see also that volatility decreases. Volatility of mortality decreases, which is an important point. So how to explain this decrease in volatility? The Nipe has a way to see it, which is, I think, reasonable. At least it's also consistent with the historical data already mentioned on medical advances. It has to do with human capital again. The idea is that when you are confronted to these epidemic shocks, repeated, you learn. As human capital increases, well, learning is part of human capital, right? Then, and well, you see at certain point, population become more important because mortality start declining, more people learning together and thinking. Then we can manage better epidemics, and that would result in much lower volatility. Here, there is also another point, which is so the guy is able to match the transition from Malthus to Solo using this kind of arguments. He has a model too, and the model is based on the fact that as mortality declines, the size of population increases, human capital increases, and people can handle better the epidemic shocks, and then we get this demographic transition, and then you have the typical story which ends this beautiful story of transition to Solo. Then I will come back with other arguments, please.
Yeah, so the same epidemics could also change the way people think about fertility, because if they see people dying around, so they could adjust fertility, and hence birth rates could also
but
change.
So I agree with you. That's you see. I don't remember your name.
Benston.
Thank you. So this is a story of the late 18th. Here in Sweden, you see that the fertility declined much later. You see, not the case in the US, in other cases. It's specialized in Sweden. So the story told is, first, human capital will serve to, I think it's reasonable, say we learn more and then we are able to handle better the epidemic shocks, which allow to reduce in a way the impact on mortality. The shocks are always there, Like if you look at the model, it has the same epidemic shock operator, let's say generator, for the whole period. So the epidemic shock are always there. If you see this change in the volatility of mortality, it's not because the shocks are lower exogenously, it's because of the reaction of humans. So they handle this. Population start increasing, human capital increases, and then you have something more related to the quantity-quality trade-off, that's fertility decreases, etc. But at the end, I want to stress the fact that the guy is talking about something different from Gallor and Weil. It's that human capital is increasing and consistently with our story, actually, early enough to help decreasing the volatility of mortality and manage better the epidemic shocks, which are always there and which will be almost with us for the rest of our lives. So this is the second theory. We are traveling through the theories. So after imbalance effect and endogenous growth theory and this unified growth theory, I think you have to speak in my head, sorry.
So this, but this is a period which also coincided with tremendous medical advancements also,
yeah,
right?
At the end. In 19th century, yes, here at this period, yes, absolutely.
Yeah.
So, but this comes also because human capital has increased. You see, that's why I was saying that his timing is correct, because what we see, well, maybe I can show you. I have this. Oh, good question. So we have the answer here. So the guy, so David Delacroix is one of my oldest friends here. Wrote many things together. So he has this paper in Mathematical Population Studies, which you might not know. It's a mathematical. I was the editor of this journal at a certain point in time. So he has a very clear theory of medical effectiveness evolution over time, with also a very good empirical. So if you can look at this paper, if you have questions, then I can then. Now, I think there is no problem in terms of adequation, historical adequation with what you say, these medical advances. Yeah, please. No.
One quick question.
Even if it's not quick, it's okay.
You showed the graph, I mean, in the last slide. And you commented that the exogenous model of shocks, that's stationary, I assume.
Right? Yeah. They have something complete.
What happens to the limit of the volatility? I mean, is there a one-line comment to that effect possible?
You mean that? No, this is how no, the generator which is in the model is stationary. It will not change. It will.
And then here the exogenous object.
This is yeah. So what the model says is that when human capital increases, then the impact, because we have this reaction of people, then the impact, the real impact, the effective impact on mortality is flattened. That's what he said.
And in the limit, what happens?
The limit, there's nothing. This is an historical data.
Oh, no.
In the model.
Yeah.
Well, I don't remember.
Like, does the volatility go to zero or something as t tends
to infinity? It's still there. It's
still there. Right?
So the guy is just interested in a certain period of time. So it does not look when t goes to infinity. It's not his problem. Huh? So he's trying to rationalize this. Okay. Yeah. And then he stops there. So that's, it's about. You have a look at the paper, and I don't think there is anything strange here either. But the objective of the paper is really to explain this. What do you think about the theory? It's good. It's a beautiful theory. Yeah. It's very clever. This guy is very clever. You have to read him more often. So it's always when I give this kind of lecture, it's always to do the promotion of people I like. that's because I believe, but no, not because I like them, because they do very good job, according to my judgment, of course. Okay, so yeah.
I was curious to know one thing.
Yeah.
So in case there are two shocks that may coincide or that are very close in time, so suppose the post-war period may coincide with an epidemic, and we observe something empirically, how do we disentangle the effect of a post-war period with a
we do like
epidemiological shock?
historians, because you know, in real life there are many things occurring at the same time. So especially now, nowadays you have a war there, you have post-COVID there, you have oil markets like becoming crazy. What we do is we incorporate this way, what I told you before. What we do in this paper, for example, is when we have these different shocks occurring, these different stochastic processes underway, we run what we call counterfactuals. We shut down things and we see exactly. Of course, we had the counterfactual is we are using a model, a theoretical model, which is itself biased because but this is the unique thing we can do. That's it's actually double counterfactual, because we have a model which is itself a counterfactual of reality. So that's a discussion, but that's what we do. You know, you use counterfactuals in your, yeah. So what we do, different counterfactuals and things like this. And then we have a story, we have a model behind. I think it's the most we can do. It's very complex when it goes to the history of humanity and this very heavy trends. It's difficult. So we can just open our eyes and our minds and try to combine different things. Okay, so this is the last thing I want to. It will take me. I think. What time is it? 10 minutes only. Yeah, but maybe just we talk and then okay. I speak a lot, so that's okay. So this is the last. So we have been basically surveying almost all the kind of literature before the COVID one. This is the third and last. We have been working on the plague and epidemics of the past and etc. And now we come to something which has been absolutely fundamental in the literature of development and growth in the last, let's say, 2 decades. Okay, and it has to do with the economics of enduring diseases. I started actually. I don't know if most of you have a different view of this. It started really to be extremely important. There is some literature before, of course, before AIDS and HIV. Malaria, for example, has attracted lots of papers before, but this one was really important because it was, in my view, it was important because it touched, first of all, the Occidental world. Otherwise, if it would have been concentrated on Africa, I'm not sure it would have suggested. Sorry for this comment, but it's politically incorrect. But that's what happened. It became something like a major field. Well, fortunately for us, because we could have we could then contribute to this. So this AIDS literature was absolutely massive in the since the 19th, I would say, in econometrics, in economics, in growth, etc. Concerning, then probably the first wave of papers in which health. It's curious talking about epidemics that the health variable is not so important in the previous papers I was surveying. I'm talking just about mortality shocks and things like this and human capital. And here it's the first literature in which we talk about really very seriously in growth and development, or especially in growth, about human capital, about health. So there's an explicit modeling of health expenditures, I mean, and all the implication of health expenditures on savings, on growth, etc. Many frameworks which have been elaborated in 17, like the Grossman, etc., have been resuscitated here. I think Mausumi and Chanka took a different view. It's simpler, but still it's there. and many applied work. So basically the question at that time was, what would be the impact of AIDS on growth and development? Everybody was asking this question because you know that although the epidemic was global, most of the deaths were concentrated in the south. In certain countries, like Botswana, which is a rather successful country, by the way, from the economic point of view, life expectancy dropped in a couple of decades from 60 to 40. So you see, I was talking about the Benporat effect a few minutes ago. So that was really an amazing period in terms of research and very alarming actually for Africa, especially sub-Saharan Africa. Okay, so what I wanted to mention here is on this. I will not dare to say thanks to this, but with this very big problem at that time, we had an emerging literature on the socio-economic impact of pandemics, which is new actually in the economic epidemiology. But before this crisis, nobody was written seriously on the distributional aspects of epidemics. And then here you have Shankar Chakraborty, who has worked a lot on this, and he has this important work with Mausumi in 2005. I worked also on the distributional effects, but I worked more on the impact on fertility, actually, which was my main publication in this field. It actually came with a very big controversy. I have how much time? But if I finish in 5 minutes, I can finish it later, right? In this 5 minutes. Just finish with this one, and then I will let your. But I will not reach your part. Doesn't matter. Okay. Yeah, it's if I ask you the question, do epidemics reduce or increase or do not change fertility? The fact that you have an epidemic, does it reduce the number of springs families have or not? So typically the demographers with whom I have been working for years and years, still working with them, consider that the impact is zero. They are not, so they consider that there is no reason to believe that epidemics may have significant impact on fertility. That's their view. Economists is different because economists think in terms of mechanism. So at that time, there were two researchers fighting there. One is Kalemios-Khan. I don't know if you know her. You certainly know her. So she's a tough lady. So she was claiming that epidemics should increase fertility. The argument is simple and applicable to African countries. Children are assets. They help. No, in agricultural economies. So there's like a hoarding effect. When there is a mortality shock, there's like an insurance effect playing, and families make more children. That's the argument. It's an uncertainty hoarding insurance effect. On the other hand, there's a very big guy named famous guy, this one, Alwyn Young, who published this. I like this paper. It's not, I'm theorist, so normally it should not. I should not be passionate about it because it's completely empirical. It uses VHS, etc. And the idea of this guy is very simple, and he argues just the contrary. He looks at VHS, this survey on health and different waves. In Africa and South Africa, precisely if I remember. Yeah, South Africa, it's written there. And he found that fertility decreases actually. And there was a war between between these two. I'm very interested in this kind of controversy, but intellectually it's interesting. The argument of Alwyn Young is the following. It's close to what I have been telling you about this American historians, David Hurley. When you have a big epidemic like AIDS, then there is, remember how many people have died in Africa. in this case, you will have a very, very big shortage in labor supply, specifically because it's like the Spanish flu. It's an epidemic which killed primarily young adults. So very big shortage. So at that time, argument is the following: wages will increase, women participation in the labor market will increase. There is like gender bias here. Women participation will increase, and then fertility rate will decrease. That's the argument of. There is no theory behind, but there are some equations behind, but they are not, as a theory, I will not consider this as a serious one. Okay. What I did with my PhD students, so that's kind of papers you could find in Journal of Economic Growth at that time, which is now a very important journal. At that time, it was not that important, but yeah, and we have this kind of papers with overlapping generation. And this one also, you see, which is more on distribution. So it's also controversial. So what I will show you here is just the approaches. I will not show you the result. Maybe I will not have time to finish. If you tell me I can stop, and then I will. I stop or I continue. Yeah. I can continue after the break. Yes, I think it's good that I will not show you I just want to show you two types of generic models. Are general, flexible, such because you can take them as they are and you can improve them. Okay, you can improve them to explain. Well, if you have a real question, and then they are flexible enough to be augmented with further ingredients, and then.
Actually, I'm still a bit unclear about that paper of legal law that you had shown.
You like it, eh? I am sure that was objective, actually.
So, yeah, so no, that graph, yes, this graph. So you had said about the human capital accumulations. I'm still not clear how is it different from the unified growth theory. So they also talk about this.
It's a good question. So here the human capital plays a role for two reasons in different periods of time. It plays a role here. Here, you know, as the volatility decreases, that explanation given by the guy is that people, in the meanwhile, as volatility start decreasing, the size of population increases, human capital start improving, which is consistent with our theory that there is an early increase in human capital accumulation. And this human capital will be instrumental in managing differently, more efficiently, the epidemic shock arriving, which reduces the volatility and paves the way to the third stage of, if you like, if you want to put it in the language of unified growth theory, this role of human capital would be specific to bring the economy from Malthusian to post-Malthusian. And then from post-Malthusian to solo, then you have the second mechanism, which is based on, someone talked about this, decreasing fertility. You know, that's the story. So that's why I'm selling this theory. It's not mine, but I'm selling it. He asked already 2 questions.
It's possible that I could have missed it, but ceteris paribus.
I cannot hear you. Can you come a bit?
So is it okay now?
Yeah. Okay.
Yeah. So what would be the long run effects of the nature of the epidemic, whether it's contagious or not? Will it have a long run effect? I don't know.
It can touch what?
If it is contagious, say like AIDS example you were giving vis-a-vis COVID, which can be transmitted just like, unlike AIDS. So in that, will there be a long-term effect in these two different kinds of?
Okay, so your question is about whether different types of epidemics with in terms of infection mechanism will have different impact. I will show you the second lecture some attempts to unify this, to have a model which considers different with different parameters, you see, which include different types of contagion, could be vector borne or not, like COVID, and very difficult. I can tell you, yeah, they are different, etc. But what I can tell you is that there is a unified framework in which is complicated, and there are many mechanisms playing at the same time. You see, there's not only contagion; it's also recovery, the period of immunization. If you are, so I'm unable to give you a clear-cut answer to this, except recognizing that it's a very good question, and then we have to think about it. But it will be treated in the lecture structure.
Let's wrap up now. Thank you. You can ask later.
Yeah, or today, or no, or now.
Thank you very much, Raouf, for setting the stage, so to speak, by looking at broadly at the literature. And please do come back, join us in half an hour for a more exciting session on this topic. Thank you. Join us for tea outside.
You need your micro, or you have to take it back.
Can I ask you the question? The linear equation for the human capital formation after the
before, just stop me. Yeah, this I need it. If you remove this from this, I will not be able to.
I was asking the question that does it make sense to have change in consumption addition
Here. So
yeah.
how would you write it? And then I will tell you.
So it would be a negative thing. So let's say why not?
No, you cannot do it here, because one thing which is important here, this is auto education. Huh? So
Yeah.
a guy is devoting part of his time to producing and the other time to educating himself.
Yeah.
Okay. But so if the consumption will show up in the yeah, basically here it does not show up because but because it's only here.
Yeah.
Okay. So it's here.
Yes.
It's here. It's like an accounting.
Oh, that's already doing it.
Yeah. It's an accounting stuff. It's not. You have a more behavioral stuff in your mind. If you want to put something behavioral, have to put it here. In utility function. That's like something like habit formation or things like this. I have not seen this before, so you can maybe try it and tell me. I will not run with this run work.
Regarding the graph,
You. Yeah, it's working. It's working. Right.
All right, should we start? I think most of us are back. So in the morning session, Professor Raouf Boucekkine talked about how economists deal with episodes of epidemics. He spoke about various unconventional interventions when we are in an era of epidemic, and unconventional economic responses interventions. Then he also talked about one sector and two sector models based on disaster theory, where the one sector model predicted growth miracles, but this was after an epidemic, but it was not consistent with our empirical observations. So he even went further to propose the, he even discussed about the two sector model whose implications were more consistent with empirical observations. He then also spoke about some implications of fetal origin theory and unified growth theory, which were very interesting. And for me, it was for the first time I was looking at the results of those theories. And we're looking forward to more such insightful analysis and discussions in this session.
Okay, thank you very much, dear colleague. Yeah, so we ended with, I want to spend like 5 minutes, not more, to finish the first lecture. Since we had very good questions, so we are a bit late, but that's not an issue. Even if we don't finish, the important thing is to exchange. So we don't hesitate to interrupt me at any moment. I told you that the literature, I would call it at the minute the economic epidemiology literature, was rather specialized in, well, basically economic history, and especially this disaster approach started by Jack Hirschfelder. And then came this AIDS, HIV crisis with all these massive contributions I mentioned. And I told you I would talk basically about two frameworks, not really the results, well, very briefly the results, but the kind of frameworks that have been developed have nothing to do with the initial growth theory, but something which is more related, well, more easily adapted, I would say, to the discussion around AIDS, which are about long-term discussions, long time, not short-lived periods. We're talking about enduring epidemics. And within this framework, which will be overlapping generation frameworks, nothing to do with what we saw right now, we can discuss many things like inequality, how epidemics, or let's say, in other words, how mortality risks, say evolution, can impact institutions, inequalities, and also behavior, individual behavior. In the face of mortality risk increase or decrease, do people change their behavior? Well, the answer is probably yes, in many respects, in schooling, in risk-taking, in fertility. I'll just mention very briefly, two frameworks, overlapping generation, just for you to see how we can deal with these questions for enduring epidemics in an overlapping generation model. Overlapping generation means that we will have a number of generations. Well, for this case, 2 to 3 generations. Suppose that one generation in 20 years, so our models for 20, 60 years, 40, 60 years. Of course, we will have also a typical dynamic analysis, steady state, etc., etc., etc. Two things. I will talk briefly about the controversy on fertility. I mentioned the position of Kalem-Lioskan, the insurance effect. We have an epidemic shock, an increase in mortality will increase the number of children by an insurance effect. And then the story told by Alwyn Young in his famous 2005 papers that an increase in mortality is a gift for the dying. That's the expression he used in the sense that in the long run, if fertility decreases as he believes, then in per capita terms, the economy will be better off in the long run. So those who die today are paving the way for a brighter future and more comfortable future. So there's a controversy. We wrote with my 2 PhD students this Journal of Economic Growth paper in 2009, in which writes, it's like a general framework. I would not dare to say general. I would say it's a flexible framework to talk about mortality in overlapping generation. So it's a 3 It's a 3-period overlapping generation, one good. Basically, if you are born in period T, you do nothing in period T. Well, we do not formalize it. Just say that the important thing here is to introduce a probability to survive from childhood to young adulthood. So there's a probability to survive as child to become young adult. Then in young adult, when young adult, you have a probability PT plus 1 to survive as a senior adult. That's just to introduce a structure for mortality. So we have 2 types of mortality, child mortality and adult mortality. Okay, you remember? And then there is something which is different from the paper I will present later, the one of Shanka and Mausumi, which is that we have an annuity market here. Okay, so there is a rate return to saving, which is equal to normal interest rate divided by the probability to survive to the adult. What's interesting also is that we endogenize fertility. When the young adult consumes CT plus 1 and decides how many children he will have, NT plus 1, okay, he also works, okay. Of course, if he decides to have NT plus 1 children in the period when he take care of them, he has to devote some time. That's the cost of having children, okay. And that's it. That's the story. It's very simple. Then you can add many things around. So what is the utility function for the young adults? So you see, he consumes. We take isoelastic functions. He likes having children. QT plus 1, NT plus 1 is, if you want, the number of surviving children. So that's important. That one thing which is systematic in this kind of models, at least from the behavioral point of view, is that NT plus 1 always comes multiplied by QT plus 1. That's, you are only interested in surviving children. And then this is utility from leisure. So one is the unit endowment of time. You work and you take care of your children. So theta is the unit, the time you have to devote to each children. And then you have, if you survive, then you have to, well, you enjoy consumption, and then you have the typical intertemporal budget constraint under perfect annuity markets. Okay, so you cannot find easier than that. Basically, if you find easier than that, tell me. That's that's easy, completely easy. And then you can discuss the controversy within this model. That's not complicated, and you can do it. So we first solve in partial equilibrium that's given prices. Prices are exogenous, and what we prove here is that that's just a word. It's just a stupid algebra, and then you get the results. What we find is that a decrease in the survival probability, that's an epidemic shock in a way, always raises fertility and reduces labor and saving. That's something which is classical. You find it. I don't want to spend too much time. In our case, it's trivial because it comes directly from annuity markets. Okay, so if you have this, okay, so remember, for given wages and interest rate, if there is a mortality shock, fertility, the mortality shock for, I would say PT plus 1, adult mortality will decrease fertility. Okay, that's one. What happens for child fertility? Well, in this case, I told you, it's always multiplied by NT plus 1. So if you have a decrease in fertility, in mortality, in child mortality, and survival probability, I would say, of children, then you will have an increase in fertility, in total fertility, but the net is 0. You know what's the difference between total fertility and net fertility? So total fertility is the total number of children which are born. Net is minus those who do not survive. Okay, so here clearly, since we have this QT NT plus 1, so we don't have the story told by Kalemlioskar. To be honest, here we don't have the hoarding effect. There is no impact on net fertility of decrease in the survival probability of the children. So, and then we look at the, I will finish with this very quickly. We look at the impact of exogenous prices. Look at wages. If I increase wages, if the wages increase, then the labor supply increase, of course, but then fertility decreases. That's the Alwyn-Young story. Remember, wages increase, fertility. So we can get the Alwyn-Young mechanism with this. Okay, and then we get to the general equilibrium, have a production. Yeah, please. Yeah, man.
So the hoarding effect is absent because do you have anything about the child mortality risk versus the adult mortality risk? Is the child mortality risk higher so that they can actually afford to wait and see what happens to their child and then decide? Why is the hoarding effect completely absent in this?
Yeah, here because we have this simple modeling in terms of in the utility function, you see, what we put is this. What's important is the number of surviving. Okay, so the target optimal value you get is on QT NT plus 1. So there is a direct impact on, if there is an impact on QT, it will be compensated entirely with NT. That's it. So there is no impact. We don't have the hoarding effect at all. We can have it if we introduce something a bit more complicated, but it will not. Our argument is very easy, I will tell you. But you are working on this. So if you are working on this, then I will tell you something which is really interesting for you. I'm not against Calimlios-Khan. I'm just saying that that's what we do. Yeah. Let me finish to answer. So what he was saying. Look, about the hoarding effect. You can tell me that I'm eliminating from the beginning, which is true. But our argument is also, I think, if you are serious about how the decision on fertility are taken, you would not consider that it's a problem of intertemporal programming, that you program that how many children you will have. And if you have something more sequential, then the precautionary demand for children, so-called hoarding, will disappear. So if you look at this not very known paper, you know Matthias Dubka? It's a very famous guy. So this is not his most famous paper. It's published in the Journal of Population Economics, which at that time was a minor journal. Now it's all becoming important. Then having this hoarding effect requires accepting the idea that people make a super programming over time of children, which is not the case in developing country at all. You know perfectly that's more sequential. Okay, so we remove it from the beginning. Please.
So are all these results at the steady state?
No. It's a time. No, it's time. It's for given time t. That's optimal decision at time t. So we complete this with general equilibrium. So the production is the production is Cobb-Douglas and etc. You see, and then you have full depreciation of capital, and you have this evolution of law of evolution of population. That's completely standard. So we embed the individual decisions into this model. We write the equilibrium condition, and we compute the general equilibrium prices. Okay, and then so now WT plus 1 become an endogenous variable. Okay, and when you do that, you find this. If you have an increase, so let's take infant mortality. How do infant mortality change the prices, the general equilibrium price? Then we have the following. If we have a decrease in QT plus 1 because there is an epidemic shock, then there is no impact on equilibrium prices at all. Which is not surprising because they're not working, right? So that you don't have any. So if you combine with the partial equilibrium result, we have a super clear result. A rise in child mortality does certainly increase total fertility, which is not against Calimlios-Khan at all. Huh? But then the interesting result is for adult mortality, which is our point actually. For AIDS, the most important mortality is concentrated around adult. So I've just told you that we have to combine the partial equilibrium result with the general equilibrium result. The partial equilibrium, we know that if TT plus 1 increases, then we have that fertility will decrease. But now we have an increase in wages. Okay, if I remember, PT plus 1 causes wages to unambiguously go up. And we know that if wages unambiguously go up, then we have a reverse impact on fertility. So we have complete ambiguity. So our result was to say the impact on epidemic shocks on fertility entirely depend on speaking generally, entirely depend on the age profile of mortality. So depending on the epidemic, you have an age profile, and then we know that each type of mortality, infant, young adult, etc., has a different impact depending on who works, who doesn't work, and etc., etc. And our general implication is that for sure, a rise in child mortality leads to a rise in total fertility, but the effect of adult mortality is ambiguous. So that was our contribution in the debate between these guys. And I think it's difficult to find a more elementary approach than ours. And if you take the things as they are, so I encourage you to follow this line of research. If you see that there are many things there going into opposite directions, well, write your own model, the simplest possible. And that's what I did. This model, I did it in 2 days. I'm used to very complicated mathematics. This one is not really complicated. And you see clearly the ambiguity. That's why demographers do not want to conclude anything. And it depends on the case. It depends on. Okay, my friends. And then I move to the last. Well, Mausumi would, yeah, please. I think you have to.
Suppose I have the probability of child mortality QT plus 1 outside. So probability of a 7. Then the same ambiguity will show up.
Yeah,
there
it will show up
well,
again.
Right?
Yeah. And then we made the same exercise with the different type of, if we change, that's what you did in your paper here. If you don't use perfect annuity market, you get also the same results. So this is the ambiguity, you will find it. And then it's not very necessary to fight on something which is ambiguous from the beginning. So we have to specialize to change to have something. So this is the second thing, which is rather innovative in the literature of mortality, epidemics, and development. It's the impact of epidemics on inequalities, which is actually important now with COVID, because those who are infected the most by lockdown are the poorest. So there is a huge ongoing literature. As editor, I'm receiving so many papers on that with new results, new approaches, etc. So here I will give you just a model to tell you how we can do something but I don't want to embarrass Mausumi, but just like my model, this one is really easy, flexible, but the mathematics behind are much more complicated to prove the results, because it's about distributions. You move from pointwise variables to distributions, then you change the dimension. You are in infinite dimension, so the results. I'm not sure you prove everything, but you have, because it's very, I can tell you about this. It's extremely complicated. So here it's easy. You have, it's a 2-period overlapping generation again, and the probability. The key thing here. The key differences. There are 2 key differences with my model. Here, the probability to survive from youth to old is under T and PT were exogenous, but in exchange, in this case. There is an exogenous fertility, and in my model, everything was about endogenous fertility. So what's assumed? Well, that's not really an issue. Okay. So here fertility, but individual give birth to a single spring before they realize, etc. And the important thing here is the distribution. So 2 things are important. One is that the survival depends upon the agent health capital. Here it's about private investment in in health. It could be also in human capital. So, and this is not contradictory with what you can see in Africa. That's my area. Typically, health expenditures are private, curiously, but not curiously, actually, if you think about it 1 minute. So that's one thing. And then, of course, health depends on the money you have in your pocket. And people do not have the same amount of money in their pockets. Okay, that's the story of inequalities here, actually. And what Mausumi and Shankar work on is in this distribution of wealth. W is wealth. So we don't have the chance to have a big, all of us to have big wealth when we are born. So there is an initial distribution and at zero, and then this distribution of wealth changes over time because of the decisions we are all making. If there is a government, the government can act also by, for example, subsidizing health, a public health system, etc. But here in the benchmark, there's only private. It's a benchmark, actually. They have many extensions published and unpublished, if I believe Shankar. So. Okay, and then here is the crucial stuff. Altruism. How it works? Well, via bequest. I don't have bequest in my model before, you remember? So here we have bequest. Now, it could be the case that the guy, before getting to the old age, well, dies because he doesn't have enough money to invest in public health, so he dies. How this works? Well, that's the beauty of the paper. They have this double, two types of bequests, intended and not intended. It's intended if the guy survives, he can decide about BT+1, okay? And if it is not intended, then the savings which are done in the first period by the young adults go directly to the offspring. Remember, there is one offspring per adult. So you have this double, well, these two classes, which is not deterministic. It's Markovian because you have a probability to be in each of the two categories. And this makes the problem complicated, really, mathematically speaking. Not in my model. My model is completely elementary from A to zeta. So the utility factor for the guy is born at T is consumption when young, consumption when old, assuming he survives. If he survives and the probability is phi HT, H is his health capital, or health investment, if you wish, then he will enjoy consumption when old, and he will leave some bequest to his children. That's it. And then the constraints per period are, this is initial wealth. Imagine here, everyone has his own initial wealth. The guy works, or at least he can work. He has, in this benchmark, he has a constant wage, W bar, and then he saves and he invests in health. If he survives, then he gets this. Here we assume that gets always the same wage. He works. There is no disutility from working here. Okay. Of course, you can show. The story is given W, what could be the optimal age. Okay. And then, of course, we can even stop here. The story is that if the richer you are, the more you can afford health and the more you will survive. And the more bequests you can leave, and this is the mechanics, the first mechanics. If you add, the beauty of the model is that first you increase this very easily. For example, you can suppose that, health also would allow you to be more productive at work. So you will have better wages here. So you could put W, it's your model, by the way. So you can make this W, you can add another engine of inequality, etc. You can introduce public health, you can do many things. Education, that's actually you do education. Okay. So the mathematics are complicated. I will finish with this because then I will spend time on this. Because basically what we have, actually we have two possibilities. Either you die or you don't die. If you die, you will have, you leave this savings, will go to your offspring, and this will generate a certain law of motion. I will tell you, if you survive, then you live this. So there are two different ways, intended, non-intended. And it turns out that with this kind of specification, optimal age will be a function of wealth. That's what I told you. It's a normal good. The more you have in your pocket, the more you can afford in terms of investment. And then you have this law of motions. You have these two cases, two configurations, I would say, and the wealth dynamics will be driven by these two things, actually. In a Markovian way, because the probability to move to survive to the old age is endogenous and dependent. Okay, so what makes the model even complicated is the fact that I took it from the fact that the optimal age, which depend on W, can be concave convex or convex concave. So it's complete disorder. It's a complete mess. And then what you will have when you study this law of motion, the one I showed you just before, this one, knowing that the optimal NW is concave convex or convex concave or whatever, will generate, if you know something about the discrete maps like this with concave convex, means you have, I don't know how you can prove anything here, but it's numerical. Okay, it's case studies, as we say. So you can have different stationary invariant situations, I guess, with either convergence, which is for me unlikely, but most probably you will have polarization. Then the mechanism which plays through the fact that your investment in health depends on what you have in your pocket will create already a mechanism which will make inequalities persistent even in the steady state. If I engage in the mathematics of that, it will take me 6 months to prove everything. So I prefer not to engage at all. So that's it. I showed you two frameworks, overlapping generation, which actually replaced completely growth theory by the beginning of 2010. Much easier, except this one. That's not a good example. Let me show you mine. It's much easier, you see. And you can plug many of the economic questions you want to study within. Don't kill yourself with mathematics, basically. Overlapping generation, it's much easier, and you can do many things to complement this with empirical analysis. Okay, so the conclusion of that is that then it finishes my first lecture a bit late, but that till the COVID break related literature, the economic epidemiology was basically that's dispersed, I would say, across different topics, across different sub-disciplines. One is disaster approach, which is about growth theory, basically, imbalance effect theory. Then it's very hard to see in this kind of literature in which epidemics are basically confused with mortality shocks. Difficult to see health expenditures, difficult even to see epidemics. Epidemiological, there's only one exception. This is a paper by Shanka in Journal Monetary Economics 2010, in which there is some epidemiological transmission there. But all the others are like me, actually, with mortality shocks, nothing more. What happened with COVID is that everybody has discovered in our profession, economists have discovered this compartmental epidemiological models. Yeah, Sire, et cetera, which actually were much less important in the past. I'd not say that they didn't exist at all, but if you look at the early papers with some epidemiological modeling, well, you will find them in health economics, not in, I think Shanka's paper is one, if you count everything before 2010, it's the first paper which puts some infection transmission in the model. All the others, well, only two actually do some, borrow some math epidemiology modeling. this famous paper by Chauffard and Philipson in 96, which is not very good in maths, actually. This one is much better. Versowitz and Hammer. I will comment on it in a few minutes, actually. But the Epi-econ, what I call Epi-econ, is the combination between epidemiological model and economic model. It only started really seriously with COVID, discounting what Aditya Goenka did 10 years ago. I will talk about this in the next lecture, which will happen now. No, I don't know what to do, but.
You were just taking into account on population, that is either you survive or not, but epidemics can also decrease productivity, that is make the person.
I have a paper, well, not only me, I think the first guys who came to this to evaluate the economic consequences of AIDS, I cite two guys who really started this. They were working in the World Bank, Cuddington and Hancock. This in early 90s, and of course they consider different channels. One is that, of course, if you are sick, that's what we call morbidity.
Yeah.
Is that you are less productive.
Yeah.
That's what I did. I have a paper in 2016 on the South African economy with my two PhD students, not the two others. Which is published in the American Economic Review Papers and Proceedings, in which we evaluate the impact of AIDS on the South African economy, accounting, among others, on this. But I have the impression that this is not the most important thing. What's the important? Oh, it's finished. The most important thing works actually, I think, through the impact of expenditures, health expenditures, which is a big drag on the money of people in Africa. I'm not talking about Europe here. let me be precise, and also on their survival, which is important. Okay, let me move to the basic models of.
Before you move on, can I just,
of course,
because that was the theory. So I don't know much of macro, but I'm an environmental person, so I worry a lot about things like externalities. The problem I find with this kind of work is that it's all a very private agent kind of a framework. Is that correct? So even, for example, health being a function of wealth, what about externalities? I mean, to me, a more satisfying way, that's just a personal preference, would be to think of some sort of a social planner. For example, when you're thinking of health capital, the state has a big role in providing that.
Yeah, but
the whole models here are all very private. It's my wealth, and also these risks, the P's and the Q's are all exogenous.
I got your point. I will talk about externalities after. But here it was a very precise problem. The question is, who spent or which institution spent on your health in Africa? Question. Not the state. It's from your pocket. So this is unquestionable. So it's a private decision, unfortunately. But then the question you ask is, given that people should rely on their pocket to finance their own health in Africa, I'm not talking about, why don't we go for a more public health system in Africa? So that's a very good question. But I think the framework which I developed here, citing other friends, is perfectly adapted to Africa, because there is no public health system. Precisely this kind of papers put on the table the necessity to build public health systems. That's fundamental. I agree with you with the idea that the externalities are there, and then the externalities will be much clearer now when we talk about contagion and epidemics. By the way, if you want a very good paper on this, on health, public health system, look at the paper by, as one very good friend of mine, Uwe Sunde, now in Munich. If you just Google him, he has a very good paper on the role of public health system in Europe and the takeoff of the European economies. He basically, with his student, he started work in the creation of public health system in Europe from the end of the 19th century. And he shows clearly that they have played an important role in the development of these countries. On the other side, you have people who are much more famous than my friend Uwe, like Acemoglu and others, which have criticized actually the view that the health is important for development, which is completely stupid, actually. Even if it's recorded, I don't mind. I have owed to typical stupid controversies between academics. On one hand, Acemoglu, on the other, David Bloom and David Canning from Harvard. And it's important for development in Africa or not? Of course, it's important. I have been there during more than 8 years. I can see perfectly that people cannot even live because of malaria, putting them bedridden for months. Well, for months, I'm exaggerating, for weeks. This kind of debate you have in academic world are simply cannot. It's typically coming from people working in their offices comfortably. They don't know exactly what happens in the field. So sorry to be so explicit, but sometimes when you are in the field and you see people dying, and you see how the hospitals are in Africa, and then people claiming that it's not important for development. That's really okay. I will.
One last question.
I will come. Please.
These epidemics, is there a gender angle to it also, in the sense that when resources are limited, they are transferred unequally to one gender, and one gender ends up bearing the cost of the epidemic way more than the other?
Yeah. We do that
in developing.
Yeah, absolutely. This is taken into account, even in the computation I've done with my team on South Africa, the paper I mentioned before. We do that, so this is also important, and it's becoming a bit less important now with COVID, because we are moving to more specific questions like lockdown, teleworking, things like this. But it's important in the AIDS literature for sure. So let me just mention that it's my pleasure to talk about this, because I have been investing a lot of my time in the recent 2 years to co-edit the special issues. This one is a special issue co-edited with Aditya Goenka and Shankar Chakraborty, in which we have published 17 papers on COVID. You see, amazing in all questions. Not only and this is another one I have just published. I have just edited for Journal of Public Economic Theory with Rabamir, in which we have published more papers on the public economics of COVID. So this is still ongoing. And as I have just mentioned before, Epi-econ models are really starting, I would say. As I just argued very quickly, all the papers which you can find in the economic literature, and which you could qualify as economic epidemiology papers, do not really model infection. They do not model infection at all, actually. That's just with just one exception I mentioned before. Now, with COVID, we know that's what's an infection. We have all been wearing masks, being confined and locked down in our houses, not knowing what we do. So we know what's an infection. And of course, the key question is, when you have this kind of crisis, it's impossible to analyze it economically without incorporating infections. So that's basically what pushed everybody, including Acemoglu and others, to introduce this epidemiological models within the economic framework. That's what I call Epi-econ. Mentioned before that there are two earlier contributors to this. I insist on Gersowitz and Hammer, because I think they are the first who really analyzed finally what they call the infection externalities. That's very well done in a paper published in the Economic Journal in 2004. It's not a model for development economists. It's a health economics paper. There is no accumulation. The guy who came with accumulation is Aditya Goenka, his wife Lynn, and other co-authors. I think, and then I will use this lectures to advertise a bit the work of Aditya, who didn't get the recognition he deserves because he worked on this much before everybody actually. Okay. So that's what I will do, and then next lecture I will talk about my own work. Okay, I have to advertise my work too. That's it. So I will be there. Okay, so what's an epidemiological model? So if you just pay attention 2 minutes, that's not really complicated. So there are many epidemiological models. It depends on actually the kind of epidemics you are talking about. The simplest one is the one which is called CIS. You have to recognize them just by looking at the letters. S is for susceptible, I for infected, and S for... So S is the initial state. A is when you get infected, and then here is the final stage. It means that you start as susceptible, eventually you get infected, and then here there is no specific death. You come back to susceptible. The unique death here is a general death. You see, we all die. There's general death means that, well, there is a death rate, which is what's the ordinary one, the normal one you get under normal. And then you have specific, the mortality which comes from the sickness, from the disease. In the SES model, the people who get infected do not die. They die for ordinary reasons, but they don't die because they got the. So this is typically, for example, the flu. We got infected and then we recover normally. Okay, so that's what. So in this case, you use SES. If the disease kills, then you have to distinguish between the ordinary. Yeah, sorry, I didn't tell you that D is the death rate. B is the birth rate. So we start with a population of size N. The susceptible are those who can be infected, basically. And then the law of motion of the susceptible, besides this, which is general term, people born minus those who die for ordinary reason. And here you have the very specific term, which models infections. Infections come from this product, S times I, when the susceptible meet the infected. Okay, that's the dangerous term here. So alpha measures the strength of the infections. The alpha is fundamental because that's the parameter which will be endogenized by the models. If you want to reduce the infections, then you have to reduce the alpha. And alpha, you can reduce it by lockdown, by anything, mask wearing, things like this. Okay, so, and then here, I just want to warn you, that's the unique mathematical point I will make here. This is a product. And these are endogenous variables, by the way. I is the infected, right? You already guessed. So when you have a product, you break down the concavity of the problem. You cannot use the typical sufficient and conditions, the second order conditions a la arrow curves or, you know. Just when you have concave, it's okay. No, this double product breaks concavity. So if you are a serious mathematician, you will be very careful in handling when you put your Hamiltonian and you write the first order, but it's not sure at all that what you are computing is the maximum. Okay, please. Yeah. So there's a question here.
So if you didn't have that term SI by N, then we would have exponentials as solutions, right?
Yeah, absolutely.
And
well, it would.
sorry.
It would be trivial.
Yeah. And the moment you have this, does there exist closed form solution?
Does?
I mean, does it have any analytical closed form solution?
No, not at all. Not at all. But you can. Well, when as long as you have this kind of nonlinearities, it's very difficult that you have. You can have in certain cases, but still you can prove some theorems, without solving. Absolutely. Well, theorems in the mathematical sense.
And are these equations now, because of that term, amenable to addition of noise in continuous?
Absolutely. You mean stochasticity? Of course. So in the special issue, we co-edited with Shankar and Aditya for the GME. We have a paper by Federico, who is a co-author of mine, actually. Federico and Ferrari. Where basically he takes the alpha, the alpha I put there, and he put a Brownian motion in the alpha. So, but stochastic papers are very rare, specifically because at the end of the day you have to solve numerically. These guys do not solve numerically; they prove theorems. Actually, that's easier. Okay, that's easier. So that's something more practical. So I just want to, yeah, please. I didn't see you.
So optimizing, if these are just mechanics, then there's no problem in having that nonlinearity,
Yeah,
right?
but then you can, yeah, but then for the steady state, you mean? Yeah, for the steady state, of course, if you want to compute the steady state here, it's easy. You just do 0, and as point is 0, etc. And then you have results on whether the steady state is free of etc. or you have an index. But when you have optimization, it's a different story. Yeah, that's what we all go for, optimization. Just want to finish. So if you have any question, please. This is basically it's all about this. Well, in the afternoon, I will show you my own way of dealing with this.
What's gamma?
I will tell you. I want to finish my description. Very good question. So you have 2 parameters which are important here. I'm just trying to identify this one. So I explained this. So the gamma, look, this is investment. This is infected people. Huh? So this term, you see, this term is exactly the same here. So those, the poor susceptible who have the bad luck to meet infected people, they become infected themselves. So this is the same thing here. Do you remark this? Okay. Some of the infected will recover, and we see them here. Recover means they come back to the susceptible. So gamma is the recovery parameter. So to summarize, alpha is the infection parameter. It has another name in mathematics, in mathematical epidemiology, but let's call it the transmission or the epidemic contagion, and gamma is the recovery parameter. Okay, so you see how it works. It's very easy. Here we have only general mortality. The epidemic does not kill. Here, the epidemic kills. There is a specific mortality. You see, there is a second mortality term here showing up. Susceptible can be killed by the epidemic, although they are not infected directly. They will die. Okay, and then wait, what's this? I don't know. Sorry for that. And then here there is DI here. Okay, this is the mortality specific for the infected, and also the recovered guy can die also. And then the general population dynamics will include this specific mortality. In the French system, we have a statistic which is published every year, which gives you what they call extra mortality, the mortality which comes outside that. So we have to put there. Okay, let me come to this first. I talked about it several times before. That's, I would say, saving the distances with others. This is the first serious paper on I would call it the seminal Epi-econ model. It's not a model about development. It's a model about epidemics and the way public health authorities have to deal with the externalities. That's exactly your question before. Okay, and it's treated like public economists. Externalities, well, there is one thing which is absolutely clear is the nature of the externality. There are many, but there is one which is clear, which is what we call the pure infection externality. The fact that when you are infected, you can infect other guys. Okay, you don't control this. You can go to the street and the other guy you infect can infect others. So there is this pure infection. The other externality, which is less obvious, is the fact that when you are infected yourself, or when you are in let's say in an epidemic context, you always think that your own action will not affect the general mortality or the mortality observed in the duty. If you wake up in the morning or you listen to the TV in late afternoon, you see that the mortality or whatever is about 10%. You don't think that you, as a person, your possible infection will change the number. You see, so and this is another source of it. So there are these two sources of externalities which are treated, I would say, somehow deeply by these two guys. Just say some comments and I will tell you exactly what these guys do. So it's the first paper, as I told you. General Epi-econ, they claim that their model will is able to capture many epidemics. I think it's total overselling. It's limited, but it's at least they do something serious in the analysis of externalities, etc. I have a model in which it's basically a sire model, the one I showed you before. So you have S, you have I, and then you have something which they call an infectable, which includes recovered plus immunized. But when you read the paper, you see clearly that this guy know what they are talking about. Sometimes it's not the case, but they are very good experts. So you see, they are not very deep in the mathematical analysis, but they are very good in health. After all, they are paid for that. So they are very good, and then they focus on the typical thing what public health economists do. They identify the externalities, that what I have just told you, the two, and then they design a program for the government to correct this. Okay, so the basic thing is, I don't have the paper here, but the basic thing is that the basic aspect of the program of the government is to maximize something which is from 0 to infinity. Believe it or not, so that's the it's discounted. It takes into account the whole population, so it's total utilitarianism in a way. Sorry, because that's my way to teach, actually. I don't used to teach with slides. I used to. So this is okay. And then they consider the monetary value. So now it's multiplied by the number of individuals. So it should be here. Everything is per capita now. Huh? So this is your utility as an individual in monetary value before the epidemics, and then they retrieve the cost of the different policies here. And then, so one possible policy, you remember the alpha? So you would say, I will have an action A, and this action A will affect alpha. Okay. So here, for example, they have to put the cost of this action. Okay. This action is a one-time constant. One? No. Here it's in continuous time from 0 to infinity. No. The A is yeah. It's you mean it's time continuous variable? It's a control variable, yes. Max A it's a control, so it's a control variable in the traditional sense of optimal control. All right, you believe it or not, but that's what they do. So oh no, that's what they do. So Practical thing is, there is a price for the action, PA, multiplied by A, and then you have to put here the proportion of the population which is affected by this. So for example, if all the susceptible is affected by action A, that you have to replace theta A by S. Okay, that's the idea. And then they, so that's keep in mind here something. So we have the epidemic model, we have the economics, but you see how the two things are connected via the A and the alpha. Because when you get to the model, so what Hirschfelder and Hammer do is to put the A here. So economics is in the, so this is the nexus, okay? And then you can have different nexus. But this is what these people do, and that's why I respect a lot this work, because they work seriously on the foundation of public health in the face of epidemics. They have a serious discussion, and they have a serious problem which they solved in a way. One thing which is probably questionable, but at that time was normal that they put it, is to put a cost for the treatment of infected. It's normal. We have people infected, and then you have, at that time, the guy we're talking about infections for which we have a cure, we have a medicament, so that it's normal that they put this. But if you think in terms of COVID, I think the most important health cost of COVID, speaking frankly, is the number of deaths, because the cost of infection is not really very big. What's important is the deaths and the fact that unfortunately many countries do not have a health system which allows to treat correctly those who are infected. It has to do with the fact that well, the intensive units are collapsed in many countries. In Africa, if I tell you the number of ventilators we have in Togo, 2 for the whole country. But it's a problem more of infrastructure than the cost of infected, because the percentage of people infected is not that big, actually. So no, I'm a bit provocative here, but okay.
I was going to ask you about the price, and you went there, but you seem to suggest, at least in their paper, this is the cost of treatment, private treatment. But if it's a government program, then
so that's a public. This is a price that's fixed by the government.
I
for
see.
given prices. Yeah,
But then that would also be related to, in some sense, the government budget.
No, these guys do not. This is really public health issue. They don't, because you are thinking like a macro guy. So this is a decentralized equilibrium, and they just solve this one for given prices fixed by the government. There's no any analysis, but it's still interesting. Okay, so now there's a big distance with respect to the big distance. There's a distance with respect to what I took this from the special issue we co-edited with the papers published for COVID. So this one is published in 2004, so 20 years before COVID. Yeah, or something like this. This one is one of the papers. I will come back to this paper later to give an example. Paper by Colkins, 7 or 8 co-authors. It's a very important paper in my view. It's one of the most subtle because it's done by an interdisciplinary group of people, not for this kind of specifications, but I will tell you why. But this is what these people do. This is the typical SIRE model they have. So we have susceptible, infected, recovered, and you see 2 things here. Now, what replaces the A of Hirschfelder and Hammer is lockdown. The lockdown with low, now it's called beta, not alpha. Sorry, I changed the notation. So they changed the notation. And then you have something which is interesting. So the rest is the same. There's no change here. Minus beta, you will find it here. You have, well, general mortality, specific mortality. You have, but the interesting thing is this one. So those who recover, so here is the, now it's alpha, sorry, it's not the same notation, I apologize. It was the gamma before. So this one, those who quit the infection category go to recovered, you find them here. some of the recovered will lose their immunity and they will come back here. Okay. And then you have deaths, of course. The thing with COVID is that if you look at the record, the percentage of people really who die with COVID is very low. It's 1 or 2%. So that's what pushes some people to argue that this is not very deadly. Still, it's deadly in a more global sense. It's changing absolutely our habits and many things. Okay, so this is a typical. I will now move to something different. As you have seen right now, I have not talked about accumulation, about human capital, about production, about anything. Okay, so all these models earlier, Epi-econ model, do not include related to factor accumulation to production. Then I will talk about this right now. That's the first who did this, as I told you, is Aditya Goenka. I will tell you this later, and then I will comment on the great variety of COVID-driven models, and then I will finish with the example I have just mentioned to show you how it is specific and how it is gives you an idea about the richness of the new COVID model compared to the previous ones. Then I will have some concluding remarks to introduce to my last lecture. I'm fine on time. How much? Only 25 minutes. Okay, I will make some arbitrages because I cannot. I have to leave some time to speak about myself. Okay. Okay. So I will present only one paper, really the first paper which does Epi-econ, but with accumulation. Okay, with yeah, the model which is used by this paper published by Aditya, I don't remember the third one, Kwon, in the GME. I was the editor in charge at that time. He knows. Okay, so he uses a CIS. So you can tell me, yeah, but this is 2014, huh? So much before. Okay, and then you will see the economics of the model. So you know this model already. I already showed you this model, by the way. One interesting, you tell me these are two nonlinear equations, etc., etc. But still, you can use the fact that population here, total size of is divided between S and I, then divide everything by N, and you get 1. That's right, everything per capita. This call it small s, this call it small I, and you see that S is equal to -1 minus I, right? So you can transform perfectly this model into a single dynamic constraint, this one, per capita. And then it becomes, I'm not saying it becomes feasible. I'm just saying that it simplifies a lot. Of course, it does not remove the non-concavity. So in order to prove optimality results here, you have really to work hard. Okay, even with one equation. Yeah, please. Of course.
This model,
maybe.
Yeah. So in this model, the death rate is same for susceptibles and the normal population.
Yeah.
But the previous specification that we had seen, so basically the SAR model, there we had different death rates.
Yeah.
Why so?
Yo, this one is it depends really. If you want to distinguish between the general and the specific, then you have this. We're talking about mortality specification, right?
Yes, yes.
So you can do that. Otherwise,
but like so susceptibles, it's not necessary that they'll get infected.
Yeah, that's true. But you can suppose that for certain reason, for a reason which is short term, they die. You can remove it also. You consider that it's not important. What's really important is, or you can here, for example, it's not included. Here you can see, yeah, here it's also, it's a bit complicated. Yeah, for example, here. But some people would only remove this specificity and replace it just with a number. Yeah, that's to simplify. So come back to this. Is it understood? So that's the way you reduce it. If you have a sire, then you have two dynamic equations, because then you have S plus I plus R. Then unfortunately you have, that's a bit more complicated. Still, it has been done by Aditya in the special issue 2021. So the counterpart of this is published 7 years later in our special issue 2021. Now remember that alpha, now we come back to the traditional notation. Alpha is infection, gamma is recovery. And then you will see how Aditya endogenizes the alpha and the gamma in a minute, okay? So just to give you some results taken from the mathematical epidemiology when there is no economics. We know for sure that just by solving the steady state and computing and linearizing around the steady state, find whether of stability or instability, we have that for sure. And yeah, this one, Hedcock, is a very good reference for those who want to engage in that. We know for sure that there is a bifurcation story here, if you look at the steady states. And the important things are the parameter B, remember the birth rate, and alpha minus gamma, which is basically net infection rate. That's the bifurcation stuff. Also, one element for you to interpret very quickly the results. Here, the story is under which conditions we have a disease-free steady state, and under which condition we have endemic steady state, to say. Endemic steady state is the steady state in which the disease mortality due to disease remains, okay? Or infection, here there is no mortality, infection remains. How to see this quickly? You see my variable S. S is, as you remember, is small s is S over n. So if small s is equal to 1, it means that small I is equal to 0, okay? So that's why you have this line. The vertical line is the S. When S is equal to 1, it means that we have a disease-free stuff. So what happens? If B is large enough, the birth rate is bigger than alpha minus gamma, then we have a disease-free steady state which is stable. What is the economic interpretation? It's what economic? What is the interpretation? It's trivial. If it means that if we have more people, say healthy people being born in massively, I would say, they can, and if they compensate for this net infection, then we can have we can have the disease disappear in the long run. Okay, but then something happens at this point. At this point, there is like a sudden node bifurcation. Two steady states will emerge. One is S equal to 1, but this is, you can see it, my friends, very quickly. You see, these are the steady state. You can compute them by putting S point equal to 0. That's very quick. So you can see it clearly. You see that there are two steady states, the disease-free, which is equal to 1, and the other, which is more interesting, is equal to beta, B plus gamma divided by alpha, right? When you zero this term, so S is equal to 1, or this equal to 0, and this is equal to 0 will give you B plus gamma equal to alpha. That's why the bifurcation appears when B plus gamma is equal to alpha. That's when S to 1. Okay, so that's it. This is completely trivial. The mathematics is 5 minutes, not more. So what we will see is that, and that's why precisely. So we have this one is lower than 1. Means that we have infection in the long run. And you see that it is equivalent exactly to the bifurcation, to passing bifurcation path to the left. That's why here you have this new equilibrium showing up, which is endemic. And it is stable. So when you pass this point, so when the sickness, when the disease becomes strong enough, then what will happen is that the disease-free steady state will lose stability and be replaced by the endemic steady state, which is stable. Okay, everything understood here? So these are the mathematics of the Cs, the SIS. Okay, so and you will see what will happen when you introduce economics. Well, the guy who introduced economics is Aditya, and Aditya, he did exactly the following. He introduced the H in the alpha. You see, you remember the alpha, effectivity. H is what? Is health. As H increases, of course, the alpha will decrease. Okay, forget about these technical conditions, but what's important is that with increasing health will decrease infection and will increase recovery. You see, positive. Okay, we put this here. Now, yeah, another link with between economics and epidemiology. The infected cannot work. Okay, so the only who can work are the susceptible, not infected, and therefore the law of motion of the workers is exactly the same as the one of the susceptible. Okay, and then we have a production function. Well, this is the difference with respect to Gersowitz and Hammer. Now we have economics and in sense of accumulation. So we have a production function with capital and labor. Okay, and that's it. I think it's the standard. And there is also a production function of health capital, if you want to understand it like this. In order for the individual to increase his health capital, he has to invest in health. It's a complicated model. Speaking frankly, it's not easy, because here you have accumulation of physical capital and accumulation of health capital. And the drivers or the controls are M for health, and for the others, of course, you have investment and things like this. Okay, here you see the static question. What is it? N, let's explain it here. Health expenditures. You see? So see, here is the, it's indeed the law of evolution of physical capital, but it's also the accounting equilibrium condition in the good market. You produce, you consume, you invest part of your money in health expenditures, depreciation, and this is how the owners of capital keeps their stock. And here you have the health expenditures, depreciation, and the same. Okay, and then the utility function is normal. Let me show you directly the program. Now, this is the program. Speaking frankly, it's not easy. That's I think it's a tour de force. Aditya and his friends could do that. So basically, you optimize social planner that should please you. Okay, and then you have the two-state equation, the law of evolution of labor, that this would connect with this, you see, okay, and then some positivity. Oh, this is the program. Huh? Oh, yeah, okay. So, okay, and then there is something which you already anticipate is the non-concavity of the problem. So you cannot solve the typical thing, but this is technical. I wanted to talk about it on the occasion of this model, but I will not repeat it twice. In the afternoon, you will not hear me talking about this. The fact that we have absolutely non-standard optimization problems. It's completely non-concave. You cannot use the typical wisdom. So you have to use non-standard argument, which typically has to do with functional analysis. I'm not sure the typical economist knows what functional analysis is. So what I just encourage you to do is not to prove it, but to make sure that your solution makes sense as an optimum. Because if you find strange solutions and you sell them as an optimum, nobody in all the papers I have referred recently, more than 100, counting the new special issue I'm doing for economic theory, nobody does what Aditya does. Aditya is crazy, actually. Let's say he's doing this, but he has a proof of optimality, which uses, but nobody does this. That's you just have to ensure numerically that you have an optimum.
Non-concavity can have types like poverty trap.
For?
In this model, can you have poverty trap? Because
it's not concave means that it's a mathematical point. It's not concave, it means that the way you, if you have a problem which is like this, okay, you don't know if you zero the derivative, you have different, you see, there are different candidates for that, and maybe what you are selecting is actually a minimum and not a maximum, you see? That's the typical thing we have. To explain it very simply. So concavity makes the analysis non-concavity makes the analysis very difficult. I'm just telling you that 99% of the authors overlook this problem. Except Aditya, he does not. Okay, so let me tell you, I will skip that. I will just show you that. This is, you remember what I show you the same diagram without economics. Now, this is the diagram we get with the economics of Aditya and his friends. There's only one thing you have, it's similar. Eh? The unique thing here you have to keep in mind, you can tell me what's alpha bar and gamma bar. I forgot to tell you, I told you that you have to forget about these technicalities, but at least this one you have to keep it in mind, yes? The alpha bar is here. It's, you know, alpha now is endogenized. So it's the limit of alpha is decreasing, so it's the maximum value for alpha h is obtained when h tends to 0. We call it alpha bar. Okay. Same thing for gamma. Now it's increasing, and you have this lower value. Okay. So if you see the bars, it's because that are defined there. So what's take the place? What replaces alpha and gamma in the Epi-econ model? You remember in the Epi model, you have this. You have alpha minus gamma here, B, etc. You remember this? And now with the Epi-econ model of Aditya, you have this. Okay. So what do you observe? Well, I would not say it's always. There are two differences. This one is not really a serious difference. You just replace alpha with alpha upper bar, and you replace gamma with gamma upper bar. What's interesting is the second, there are two types of endemic steady states here. Okay. And that's it, basically. All the rest is the same. What you see is that if your birth rate is strong enough to compensate for net infection rate, then you get rid of the sickness, of the disease in the long term, and you have one equilibrium, which is disease-free and stable. But when the birth force is not enough, then you will have, again, a bifurcation. A disease-free steady state will be unstable as before in the pure epidemic model. But you have now two types of endemic steady states. Why this? Well, here you can have an endemic steady state without health expenditures, and we can have an endemic steady state with health expenditures. So the question is, how these two things can happen, basically. Well, you could ask me, how could it be the case that we can have an endemic steady state without, for the steady state? We agree. It doesn't mean that in the transition there is nothing. Well, the mathematical condition for that is very easy. It could be the case that in the steady state, the marginal productivity of capital is much higher or higher strictly than the one of the second derivative, not the one of health. So, so what I say in the case is not health, is labor. So in this case, M star equal to 0 is perfectly sustainable by economic condition. What makes the difference between the two things is the theta. Under which condition the inequality I have just shown you hold or doesn't hold, it depends on the theta. Maybe you don't remember what's the theta. The theta is the discount rate. If the planner is impatient, that's if the theta is high enough, then you will get this, an endemic steady state without health expenditures. If the planners is patient enough, then you will get an endemic steady state with health expenditures. The two things are possible. So there is no evaluation here of welfare. What is the best? It depends on the theta, basically. If you are above, you have this. If you are below, you have this. That's it. Okay, my friends. So this is exactly what. So you could tell me. So one thing which is also interesting is an extension of this to endogenous. This is not endogenous growth. This is the model I show you here is completely exogenous growth. There is another example with endogenous growth, which is published in economic theory. Okay, I will not tell you that I was the editor in charge. I was not. But then if you want to have a look at it, it's endogenous growth and it's very interesting. And then there is a typical thing, Mausumi, where you have not only central planner, but also decentralized equilibrium. And then in this case, it's really Gersowitz and Hammer with accumulation. It's an extension of this. They really build on the externality analysis of the guy, and then they have a competitive equilibrium. But still here you have the same kind of things. The unique novelty here, when you have endogenous growth, is a possibility you will have poverty traps. Or they call it disease endemic poverty traps. That's interesting for those who work on epidemics and poverty. This is the additional option you have with endogenous growth. Other than this, the model is quite standard. And as before, the alpha is endogenized. Okay. Any question on this part? How much time I have? Very clear. So that's it. So this is the, as you said, enfance de l'art, and then you have since 5 minutes. Okay. So since well, the COVID, a very, very, very important, massive literature. So I just want to mention some examples of the first wave of models we got from 2020. Most of them actually are in the line of Greenwood of Gersowitz and Hammer, and use central planner. No behavior, no economic personal individual behavior at all. Like the paper 2014 of Aditi I have just shown you. So they have central planner problem where an authority has to choose an appropriate policy control or control policy, lockdown, timing intensity, testing, vaccination strategies when available, mixed strategies. They have social welfare function, which typically accounts for economic cost and human life losses. Nobody counts, for example, the cost of hospitalization of the impacted. That's not a big deal. The big deal is when I will show you maybe in the afternoon, because I don't have time, how people deal with debts. Okay, and that's it. And sometimes you have an explicit account for health system capacity constraints. Okay. Now, there are many examples of that. Papers by Alvarez, papers by this is published in the American Economic Review Insights. It's a new journal. This is published, Piglem and Shi, very good paper. Alvarez also is a very good paper. Published in Economic Journal, Asprey, Colkins, all these two guys are published in my special issue in the journal Mathematical Economics. And then I have written 2 reviews. This one with Carvajal, Aditi, and Shanka. This one with this mathematician. And what's typical in these papers. They are really following the guy. They're following Hirschfelder and Hammer. Central planner, homogeneous population. They don't take the diversity of people. Of course, when you are confined at home, it's not the same in terms of impact that you are rich or not, whether you are employed or not, whether you work in the informal sector or not. You see, that's very complicated. That's not the case here. They have homogeneous population. The unique heterogeneity trait they account for sometimes is age, which is normal because you know that the mortality is concentrated on elderly. That you have this paper in Acemoglu, American Economic Review Insight, Gaulier, Journal of Public Economic Theory, Fabry, etc. Have also this in my special issue, Journal of Mathematical Economics. And they all these papers actually have discrete age structure. They say, I have 2 categories of people or 3 categories of people, young, children, adults, elderly. The unique guys who work with continuous age structure are these guys, Fabry. You should know that the first model on infection diffusion with age structure is due to Kermack and McKendrick, 1929. It's very old. So this paper actually proves new results on optimality with models, epidemic model with continuous age classes. Now we have already some variations. I will finish with these slides, otherwise you will kill me. No, I will finish with that. With this, there are some variations, even in this new first wave. Well, we have models now which consider not only the typical thing, modeling of with this compartmental model. Yeah, by the way, this the model I show you. SE are called, they are called compartmental models because they have different compartments, S, I, etc. So you have models now who use, or which use, sorry, social networks. So if you are one guy, have an exogenous social network, and then they elaborate on this. One paper I would advise you to look at in this respect is Bizine and Moro and the Journal of Economic Behavior and Organization. It's a beautiful paper. And for those who like more mathematics, Mandel and Bouvray in Journal of Mathematical Economics. Okay. So beside this social network model, you have models which consider diffusion across space. I have to say that I have published these 2 papers, but I'm not really done. The video is, so I published this because I need some papers with diffusion. It's very difficult to write something high quality with this because the maths kill everything too much. I'm saying this and being myself a mathematician, but you don't see the economics at all. And then, okay. There is a long tradition of geographic modeling in mathematical epidemiology, but not very well. Yeah, other authors use matching models. It's very curious how this epidemic has inspired all the disciplines. So random matching expliciting how epidemics spread through economic activity and how lockdowns back the country process. And you have stochastic central planning, as I mentioned to you. Someone asked me about stochastic, and then I mentioned that. I gave you that. And last but not least, now people take into account that COVID has an important impact on the supply chain, disruption in the supply chain, which is actually causing part of the inflation we have now. This is an excellent paper by Bodenstein and others. If you want to read something on a model with an explicit economic sectoral structure applied to the US, it's published in Quantitative Economics. So if you want to read it, it's really nice. So it's calibrated on the US using input-output tables. That's good. Okay, and then I don't know if let's finish with this, if you allow me, just 1 minute. In all these models, you have a public authority deciding about everything. And there is no space for the response of individuals. Actually, individuals can respond themselves without waiting the government. They can self-isolate themselves, etc., etc. So they don't do that, or very few do that. What we, as I say here, they work, all the papers work for given homogeneous population behavior, which, so we have kind of Lucas critique. You remember Lucas critique? You run a model for public policy considering that people do not move at all, which is, of course, a mistake. So there is, that's why I mentioned this paper of Pizin and Moreau in my overview of the new models. So these two guys show very brilliantly that if we do not account for private response of population, endogenous response, then we will incur in considerable biases in the prediction of spread of epidemics, which would lead to wrong epidemics. They have a splendid numerical example to show that. So we have to do something with that. At the minute, we have few papers doing that, introducing some individual behavior. Example, Bouvray, Mandel, GME, in which agents invest resources to decrease infectivity of their link. But this is indeed a very reduced form of individual behavior. There is probably something more in behavior. There's something strategic. The strategic is not there. I want to talk about strategic this afternoon, but I will elaborate more with my own work on all the things we have talked about. Thank you.
Okay, if there are technical questions related to the slides, we can have them here.
Even non-technical.
Non-technical ones can happen over lunch.
Okay.
No, but I think the speaker allowed one. So since you're working in this area, I think one thing that's really important in terms of where the literature goes is that it's become like a zero sum. So I'm afraid of going to get my cancer treatment done because of COVID, or, I mean, people are putting off lots of other treatments because of the fact that there is a lockdown. So you delay very critical interventions.
Well taken. Yeah.
And the second thing there is that now there's evidence coming that like measles vaccinations have gone down. So I think in the long run, we will find that this sort of panic response of lockdowns or diverting public health resources into COVID responses at the expense of, say, doing immunizations for. So I was reading recently that the measles epidemic will start because people are not getting vaccinated. So I think that's sort of bringing in those other things, because we are now only looking at this epidemic. We're not looking at other diseases.
Absolutely, you are completely right. So now there is an emerging literature, but that's what I was mentioning about retarded effect. So the retarded effect are perfectly understood. I mean, in the sense that people understand that because many surgeries have been delayed, because many public health programs have been put in a drawer, bad things will happen in the future with respect to the populations which have been affected with this allocation or misallocation, maybe. Yeah, so this is another different, but I'm just talking in terms of health. You are completely right. So it's under study, and I didn't want to spend, but definitely I will mention this. The other thing, the issue which is not treated correctly is the issue of long COVID. That's long COVID is a very important one, not treated correctly. Many others. I will show you. I will just give you two of the works I have been doing in the last 2 years. I didn't want to publish actually on this. I could publish whatever I want in this area because I'm controlling many things. But I prefer to focus on long-term project because I see that many things are still on the table, and we'll have, unfortunately, some very bad surprises in the future. Yeah, please. This is I did compute this kind of things for AIDS because it's short bit because of the Ben-Porat effect. The schooling time decreased because the people who, instead of living 60 years, turn to live 40. Then if you compute the impact in 2030, you see something much bigger than the AIDS impact. Sorry.
Yeah, so I just had two questions.
please.
Yeah. So the first thing was just an extension to Professor Gupta's question, which is that so if you have like two different diseases, right? If a COVID control policies that affect the transmission for something else like measles, it's almost like you could have these two SIR models for different transmissions, and be fairly complicated to solve. But I was wondering if stuff like that has been done, because it seems to be very relevant.
No, it has not been done. I think it's, I wouldn't go that way, it's not necessary to complicate the maths. Here is a problem of allocation. We know you have a problem, you know it from many years. You have vaccines, you control it very well from the biological point of view. Then you have a projection on the number of people affected. Then you can just take it into account in the optimization program and not give everything to. That's what I think the professor is saying. The second question is?
The second was, I was just wondering, so are there network models, for instance, which deal with stuff of this sort? Because it just seems like you can put it on a graph and you could have edges and you could think about the whole lockdown control.
Yeah. Models like this, you mean? Yeah, that's, I have a bit reluctant. I'm a bit reluctant to use this kind of models, typically because I think that in this kind of models, what's important is the endogenous formation of these groups of, and then the literature so far has plugged something which is taken from the network literature as it is, with story of infectivity of links, completely artificial. I would prefer to model how people move, with whom they will work, they will decide to, than plugging something with completely ad hoc. It's fun, you find interesting result, but it doesn't bring something very deep.
I see, okay.
You see what I mean? Or, well, you can ask me after.
Endogenous network formation, right? You could even have these models where, the networks form endogenously.
Yeah. Absolutely. Yeah, that's what we are doing, but it's a very long-term project. We are very slow.
Thank you.
Yeah, so we are going, please join us for lunch, and those who have presentations in the contributing session, please, the rooms, all the contributory sessions are going to happen in the other building. Please show up in your respective rooms at 1:45. The student volunteer will help you to load the presentation. Thank you.
Yes, sir. Thanks.